Hello there, ladies, gentlemen and unicorns. I welcome you towards probably my longest YouTube video to date, which is the code review of my Ludum Dare 41 game, Zoccer. Oh, what you ask what I'm holding? Well, this is Barbe à Papa, a weird drink I got from sent from all the way from Belgium, from friend of Pixel Prophecy, that is Julien, who thought I need something weird to drink while doing my Let's Plays. So thank you very much, Julien, and he also sent me coffee. Lots of coffee. Okay, back to the code review. Yeah, I want to put this video onto the Ludum Dare page, where also my game is, where you can download the game and watch the video of this code review, and also download all the source code. So you can watch this video while stepping through my source. I decided against chopping up this video so that you have everything in just one video and you're good to go. Because it's so long, in the description I put a number of chapter marks where you can just jump to certain objects or certain aspects of the game if you're just interested in those. But of course it is strongly recommended to watch the whole thing, because I'm mentioning stuff in one part that might apply to the other part also, and it's just for the whole picture. It's probably good to watch the whole explanation. Pro tip: watch it at double speed because this video is really long. So without further ado, I just need to say one more thing, and this is disclaimer. I'm not a trained programmer, and this is why my implementation might be a little bit sketchy at times, but I will mention this in the review. Alright, so onwards, let's take to GameMaker. So here we are in GameMaker, and I thought I'd give you a short overview first of the project structure itself. So first, let's have a look at the objects. So I have separated them here in controllers, which look like this. The initialization controller, game controller, input controller, and mouse controller. The mouse doesn't get used, but we will get to this a bit. Then I have here some classes and some effects objects. And the player, the ball, the goal, and the enemy type, and a generic collider type. And some items here. But let's not get ahead of ourselves. I will cover these in a bit. Also got some scripts, not many. Most of them deal with the input control, some sounds, and of course some sprites, also some stand-ins and effects, and most importantly, the room layout. So how I lay out my projects in general is to start with an initialization room, this one here, where everything gets set up for the game, all the singletons get instantiated, and from then on, once this is done, the game switches over to the next room where game control handles everything. So without further ado, let's step into the init room. And this room here sets up the initial view of the rest of the game. So let's have a look here at the properties. I am not concerned with the room size or anything. All I'm concerned with is setting here the viewports, because as I've mentioned often before that I love me my viewports. And so sometimes when these things don't work, you really have to make sure that all those checkboxes are ticked, that you want to enable viewports and that you want the first viewport to be visible. This cost me a couple of minutes until I figured out why it didn't render the way it should. Because this one wasn't ticked. So my viewport is set here now to 1920 by 1080, so your average HD resolution, and the viewport is in the small HD. So essentially the game is running in full HD, but it's only being presented in half HD, but my game offers you to pull open the window or pull it bigger and have it run at full screen. So this is why the game is per default always in full HD. And the only instance we have here in this generic room is this one up here, and this is of course the control init. So let's have a look at here in my objects. I have here my controllers separated. Those controllers get instantiated usually only once. They are only singletons, and do some Hungarian notation by not so much prefixing them with their data type, but their purpose. And in this case it's CTRL or control. So this is control init. So let's close all the other windows that we're not getting confused here. And yeah, let's open this one again. So the control object here for init has only this onCreate event, which essentially says init game, which calls a script. And once this script has been executed, it goes to the next room. So let's have a look at this init script. That is init game. There are no parameters passed or anything. It's just this one here. So this script here sets the game speed to 60 FPS and randomizes the randomizer, which essentially means it just assigns a random seed to it. Otherwise, it will always start with the same seed and you would get the same items from the same zombies. So next up here we have some global variables. I know global variables are not well received usually, but I'm only using a few, so things won't get out of hand here. What it does here, this script instantiates a game control and an input control. Sets the debug to false because I have some flags there where they check whether the game is running in debug mode or not, so to display some overlays. And I'm setting up some depth values here for the user interface. The depth value is pretty much the Z coordinate in GameMaker, which tells you how close to the camera something is. The smaller the value, the closer to the camera it is. So here the mouse, for example, I'm not using the mouse, but anyway, the mouse is set to -9000, which means it is 8 times more in front of the UI. So the game usually happens at 0, and all the instances you create just get stacked on top and behind each other. So this is why I make sure that the UI is always there in front. And the global item drop chance I set here, this is the only global variable I set here. Yeah, this is probably a game jam thing where you just scatter variables all over the place. So the item drop chance is 0.3. So in general, the chance is about 1/3 of all the zombies will drop an item. So let's have a look at the game control and the input control. Those are quite the beasts, to be frank. Okay, so the game control here. As you remember, this one gets instantiated here in the init room just once because it's a singleton. And it has a create event, a step event, and a draw GUI event. The draw GUI event is apparently unused, so actually we can delete this. I'm only setting up here a local variable, which is pretty much empty. So actually, yeah, we can delete this event here. So when the game control gets created, it sets this SCR value. If you're not familiar with my way of setting things up, I like to have this one here. It's pretty much some kind of introspection. So when I'm using some debug statements, for example, show debug message, and there's been some kind of error, and I just write error. I don't know where this error happens or or why, and this is why I use this SCR, which stands for script. So this is the name of the script. So I usually go like this, and then out here in my output window, I would have always the instance event, the name of the instance and its event that throws a certain message or error. And this is why I use this usually in all of my scripts just on top as a way to, yeah, just to get the script name and the object name itself. I usually do this manually. There's this way of, oh, just got something on Twitter, that's neat. There's this possibility that's documented where you can get the string of a certain script name or something, but it is very costly. And since this won't change, I'm just using there a local variable. Okay, so as in GameMaker, you might know all the variables you want to use, unless they're local variables, you need to set up here in the create event. Otherwise, you can't use them in the step event because GameMaker will complain that they are not there or not initialized. So the game control, pretty straightforward, controls the game. So it needs to know who the player is, what or where the ball is. There are some text notices, for example, the notice, the result, and the hint, which get used at the ending screen or victory screen. So those are just, yeah, 3 slots in a way for text objects. Then what current music is playing and the names. And here I'm pretty much just assigning the actual assets to these variables. So for example, should the music in-game change or anything, then I only need to change this value here in the create event. So if it's called in-game 2 or something, yeah, I only need to change it here, and then everywhere else in the code where I might use this, it always refers to this variable name, which I think is a much cleaner way because it's indirect and you only have to change it in one place should you decide to change it. So we have music in-game, death and victory, and I'm also setting up some flags. In my case, those are, yeah, Boolean values that I'm usually using in my scripts. The doInit script, I've made 1 or 2 years back a video about how I set up my GameMaker projects. A little bit of this has changed and I've adopted some other ways of doing things, but the doInit is still the same. So in short, it means that in the step event, here I'm setting the doInit to true and defer the initialization of some other variables here to the step event. So, and I do this with pretty much any object, so that I have an if doInit, something happens, doInit is false. This way I decouple the create event from the step event, because usually if you create something in GameMaker, the execution order is like this. You have an object, for example, the init object, in the init room, this control init, and then it says to create an instance, for example, of game. And it runs the create event. But then you might want to assign some default values or some values that are not these default values that are assigned in this object here. So you can't pretty much do this any other way, apart from setting those variables here to none or no one or just some default value. Then once this is created, the other object continues its execution. There, for example, I can assign a ball or a player, and then I know that they are there. And once those values are set, the next step, this doInit event runs for this object. Jesus, I hope this was somewhat clear. If not, please write it in the comments and I will make a whole video explaining this in detail. But yeah, pretty much it decouples or it makes it possible for other objects that create this object here to set any of those variables in another object after it got created, and then this object can work with these values. Okay, so we're pretty much through with the create event here. So after this init object called this init game script here, the init game script created the game control and just assigns it to global.game, so that whenever we're calling global.game, it refers to the instance of this object here. I'm not getting into the step event right now, but we will get to this in a bit. Let's have a look at this input thing here. And as you know, you can use some pre-made code or pre-made assets in your game and for Ludum Dare, and I've made this input control for a platformer, which I spent quite a while tweaking on. But let's have a look at this input control here. I even made this little sprite icon here, which is, yeah, it's never used in the game. It's just so that it looks nice here in the editor. And you can see yeah, it's a little bit more complex than my other objects. It has a create, begin step, end step, draw GUI, and an async event. Like I said, I'm not getting into this one right here and in great detail, but suffice it to say this one here takes care of all the input. And you can define what counts as up and down and interact once and interact two. And it has this whole support for different gamepads, at least those that I own, and it allows for switching on the fly. And also that you can use, for example, just shoot with the gamepad while you're steering with the keyboard or another gamepad, for example. And yeah, it's not fully implemented. Not everything works or not a lot of button options are there, but in principle, the groundwork is there. So this is what happens in this one here. The only thing that is of concern to us is that when I'm checking whether the player is hitting up or down or left or right, it always checks this instance of control input. And there we have is jump false or is move left false or true. And what buttons I press on what control interface, it's of no concern to any of those other objects because this gets handled, like I said, here in this input control. And you don't have really a way of scoping in GameMaker, but ideally it should just expose is left, is move up, is move down, is interact to, and so on. So it's only Boolean values that I'm checking for in these other objects for the player movement, for example. So this is our input control. Like I said, if you're interested in how this works and how set things up, and yeah, it's quite a lot actually there that's going on here. And it uses some scripts which are here in the input scripts. For example, the gamepad button mapping. This is a whole script by itself, and the check input list and so on. So yeah, like I said, it's pretty complex, but we can take a look at this in another video. Okay, so now that the initialization is done, it means we have now, the game has now a game control and an input control, and this object mouse here is also in the controls because the input control also wants a mouse object, and I wasn't sure if I need a mouse or not, so I just put it in there, but it never gets used. So this is what happens in the init, and once this initialization is done, it switches to the next room. What is the next room? The next room is room title. And it looks like this. It's the title screen, which I implemented literally in the last minute because I thought, yeah, I still need a title screen where all the controls get explained. This thing here is a sprite, just in full HD. Let's have a look at it. It's just a single PhD I did in Photoshop with all the text. Yeah, it's burnt in, it's baked. Nothing else happens here in this room, that it just looks at what's happening in the game control. So let's have a look at the game control once it runs the first time the step event is run. So at this point, after do init, we are here in the room title. So we know we're in the title room. And then let's have a look at what happens on each frame in the game control. The first thing is we increment the stat session steps. Yeah, in the create event, I have here some stats that I set up. Yeah, it's just like it is. It counts the deaths of the player, the wins, the number of restarts, the game steps, the session steps, and so on and so forth. So it's just in case I'm interested in using some of those statistics, I can. And this is pretty much what happens here. It just counts each step. It increments this variable here. Now we have here a switch state, and I've implemented the game control as a state machine, essentially. So we have different, let's have a look here first in the create event. So we have here this enumeration of game state. So the game state could be main, title, running, game over once, game over, victory once, victory, and title once. And running first. Okay, so yeah, I'm not. This is already looks like a gem implementation because I'm not very consistent. This is always a postfix or suffixed with once, and this is here first. But in principle, it means when a game said game over once, this one runs here one time, and then it loops each step in the game over state, and the same is here with victory. So when victory is first triggered, it goes into victory once, and then loops over the victory until there's a different state. And yeah, so pretty all the objects there have their own state. For example, the game has its state, the enemy has a state, the player has a state. So everything is managed by state machines. I'm not too happy with my implementation of state machines because they seem a little bit half-assed, because sometimes I feel like they should be a little bit more complex or something, but it works, so I'm not complaining. So the first state we assign here in the create event is the state title once, which means the first time the title menu is run, it will execute a certain piece of code. So what happens each frame is we just switch what state we are in. Let's make this one here a little bit smaller so that it fits onto the screen. Here we go. So it just switches the game state. So if we scroll down here, this is the end of the game switch state. So the only thing that's outside, and I don't think it's necessary even that it is outside, but I eviscerated it and wired it up as a state machine in the last 10 minutes. So this is why I wasn't sure if this one needs to go in there and where exactly, so I kept it outside. So the only thing that's not in this giant switch statement is do restart level. And if we say yes, then let's delete all the object text that says you lost or you won or something. Reset the game steps to 0, restart the room, set the state to running first, and restart the level to false, because it do restart level, this one here, so that it doesn't get triggered each time. Okay, but we're again, I'm getting ahead. So let's go back to this state machine here. So we're switching the state. The first time we're here is title once. So what happens in title once? A whole block of commented out code, which is good, which is fine. This is when I tried to draw some text there, but it didn't work quite. So yeah, let's ignore this whole thing here and let's be just concerned with what actually happens. And is okay. So the first time the title runs, we just switch the state to state title. So anything that I would only want to run once, for example, create new instances of text boxes or something, would happen here. And then the next time this switch statement runs, we're here in game title. Okay, and when we're looking at this here, if you recall the first, just before I said that everything gets deferred to this input control, and I'm only looking at the input control and never at the actual keyboard presses. Well, except here. So I've hard-coded it that if you press enter there on the title screen, then the state changes. And it destroys all instances of the object text. As you recall, in this commented out block here, I had to create, I meant to create a text box or something. But yeah, so this can also just vanish. So overall, we just need this title once here. But yeah, I'm not cleaning up my code. I'm just explaining it, what you will find if you look at my source code. So yeah, we're in the game's title screen, and the only thing you can do is press enter or interact 1 in the input control. And this also gets set to true in the input control instance when you press X. I think it was X on the keyboard. Not some keyboard, what am I saying? On the gamepad. Or enter on the keyboard essentially, but or was it space? I think it was space, and this is, yeah, it was space, and this is why I made sure to put here this hard-coded enter value here. So what happens now when we switch from the title screen to the game state to running first? So the next time the game control is run, we are here in this case. It's the game state running first. So if the room is not the room game, remember we are here in the room that is called just title. So we're not in the game room, and we just instruct GameMaker to go to the room that's called RM game. And then break. We bail, because anything else that happens depends on instances that are to be found in the game room. And yeah, this was quite an essential bug that I had, which I will probably cover here that happened in this line, which I will cover in my upcoming documentary. Yeah, I was just being stupid and not thinking logical statements through. So this one cost me a lot of troubles in the final minutes of the competition, and I was close to giving up because of this. It was just a simple misconception or something that happened in the heat of the moment. But it now works like this. So if the room is not the room game, then we break. So we know that when this code here runs, we are in the correct room that is game. Let's have a look at the room game now, because it is quite something. So this is the whole Zoccer field as seen from above, and this rectangle here is the initial view on which you start. So the whole thing is not randomly generated. I just drew it like this, and this is how it looks like in broad daylight. And let's zoom in a little. And here we have the player, this is the ball, and this is a zombie, and this is the first item pack. And if you have watched my own playthrough of Zoccer, I've mentioned that I have like 4,000 colliders in there. Where the hell do you need 4,000 colliders? Again, I'm getting ahead of myself, but you see those purple boxes here? Those are the colliders, so that the ball bounces back correctly from all those obstacles here in the environment. So those are just tiles pretty much, or just splats or decals or whatever you want to call them. They're just on the background, and the actual interaction happens here on those colliders. And yeah, it's like 4,000 of them, 4,000 colliders. So when you're checking with the collision with this collider object, things are not too optimized. So we will probably get to this, how I did this, that it's halfway manageable and that it runs at a decent frame rate. But this is probably not how you should do things. And if you look at here, my layers for colliders 9, let's switch them off, line 8, 7, 6, yeah, it just it's like those are little islands, because as I was drawing those colliders, I realized that GameMaker gets really slow when you have a lot of those colliders, because I think when you're just painting on instances, it has to do all the sorting again here in this list, and yeah, it gets really slow here. So this is why I just started a new layer for each new set of colliders. So I don't think this is how you do it, but it worked reasonably well enough for me, and I'm not going to touch it. So let's get back. Let's close the title room here and the init room, and let's get back to our workspace here. So when the game is first run and we are sure that we're in the game room, the following things happen. Let's assign in the game control the player variable to the instance of the player. If the player isn't existing, or if it doesn't exist in this commented out block here, then it will create a player at these coordinates. But since I placed player and ball myself there already in the room, let's have a look at it again, just to be sure. So it will find this instance here of the player and this instance here of the ball object, and just assigns it to these variables inside the game control, so that when we're asking game control for its player variable, we always get the instance of the player and of the ball. So, and now what happens here is we deactivate. In GameMaker parlance, this means we cannot do anything with these assets of the enemies unless we reactivate them again. So this means they don't need, because these enemies have, like I said, a state machine of their own. They have a certain radius of influence where they can detect the player. And yeah, we don't need all the enemies when the game starts to be aware of the player or check for awareness of the player, when we already know that, yeah, if they're probably not close to the screen, then they won't be aware of the player and don't need to check for it. So we deactivate all the enemy objects here. Then for the music, if there is the music death playing in-game or victory, we stop the sound. Let's zoom in here a little bit like this, good. And then we switch the game, the state to game state running. So, sorry, I'm zooming like crazy here. Let's reset it like this. I hope you can read this if it's not too small. So yeah, like I said before, this only runs once to initialize it all, because we don't need each frame or each step to find the instance of the player and find the instance of the ball and stop the music and deactivate. No, once is fine. So once this has been done here, we break, and the next time this one runs here, we are at the game state running. So to recap, we're not on the title screen anymore. The game control knows who the player is and the instance of the ball, and has stopped all the music and deactivated all the enemies. What happens next? Okay, first thing is music, of course, because music is always nice. Apparently, this is my priorities. This is to first look at the music. So the current music, let's switch it to the music in-game. And if audio is not playing, so if the current music is not playing, and it is not because we stopped it just before, then let's play the current music at the priority 10, and true means that it loops. So we set the looping to true. So next check. If the player exists, which it should, then and the player state equals to player dead, well, while the game is running and the player is dead, well, then probably the game state is game over once, which means the first time to initialize the game over event, which isn't good for the player. So we know there has been a game over. And if the instance exists ball, and the ball has its own flag set that it is in the goal, so we're checking here each frame if the ball is in the goal, then yeah, victory once, the player has won. If the ball has not in goal set to true, well, the ball was destroyed, game over. This is just a debug message. I just wanted to make sure that there's always a ball in there, and if for some reason it should get destroyed, that I know at least why the game is suddenly crashing, because there is no ball. Okay. Remember when I said I deactivated all the enemies? Yes. Now we are going to selectively activate the enemies, and here it comes, the colliders around the view every second. So, What happens here, if you remember, those are 4,000 colliders, and checking if the ball is colliding with one of 4,000 instances each step, which means 60 times per second, is too much even on my rig. And by the way, having a fast computer is a curse when you're trying to optimize things, because if things, it always looks like things are pretty well, and once your computer starts choking, well, then everyone else's computer is already crapping out. So what happens here? So I'm using the modulo of the game speed. So if the game, if you recall before, I'm just incrementing at each step the global stat game steps. So if this is dividable by the room speed with a remainder of 0, which means this happens once each second. By the way, if you've noticed in my previous talk, well, it was 1.5 or 2 years ago, of setting up my GameMaker projects, I'm relying a lot of delta values, which is a good thing, of delta time and such. But I couldn't, apparently I started just with playing around with steps, with room steps. So this one here is not the correct way to do it. I mean, it works for smaller projects, and I think for a jam project it's just fine. But yeah, you should really work with delta time and don't count the game steps, but instead just the milliseconds pass or something, which is a little bit more robust. Anyway, so once each 60 steps, which means once each second, we do this. We set this local variable of margin to 500, which means I'm using it as a pixel margin around the view of 500 pixels. If you take a look at this, so this is the view here, and plus 500 pixels around it. It's just like a big rectangle. This is where we are looking at things here. So this is what this does here of LT, W and H, which means just, I think, left, top, width, and height. Yeah, we're just getting the view rectangle. This is this white one here, the view rectangle, minus the margin and times the margin times 2. Yeah, pretty much it means just we're looking at the margin and what's around the player. And I don't know why I'm multiplying the margin here by 2. Oh, of course, with width and the height. Of course, yeah. So essentially, yeah, we're just having the view here and a margin. So this is our rectangle. But what we're going to do now with this rectangle, we deactivate all the colliders. Yes, that is right. Each frame, I'm deactivating 4,000 colliders in this line of code here, and then I'm going only to activate those that are in this rectangle around the view, so that when you shoot the ball outside of the view, for example, if we're here and this is our view and I'm shooting the ball like this, that those colliders will probably already be activated, which means the ball will check against them and bounce off. But if we whack the ball really hard and literally out of the park, and let's say to this one here, then those colliders are probably not activated, and the ball will just land in this area here that is not accessible once the player is there. Oh, by the way, the view is always following the player. This is here in this room. I should have mentioned it before. You can set for a viewport to follow a certain instance or a certain object, and I set it up to follow the player. And -1 by -2 means yeah, there's no damping or acceleration going on. It just makes sure that the player is always center. Well, not quite center, but this is the border. Once they get 700 pixels close to the horizontal edges, or 500 to the top and bottom edges, the screen, the view essentially will start scrolling. Yeah, just as an aside. So yeah, this is what happens each step. We are activating and deactivating colliders as we go, so that at no time there are 4,000 colliders we have to check against. And once this is done, we increase the number of stat game steps by 1. Yeah, like I said before, this is just a statistic. I don't think I'm using it. Oh, yes, no. I'm using it to count the seconds, how long the player took to land the ball there. Again, yeah, this is not a proper good way of counting time using the game steps. I mean, it works fine if the frames per second are stable, but if not, if the computer is just chugging along and there's a lot of frame drops, then the time will be completely off. So yeah, lesson is do this always with delta time and count milliseconds or something like this, or use a timestamp from when the game was started, but don't rely on counting game steps. Yeah. So before moving on, let's have a look at the other states we have. If you recall, when the player is dead, when the player instance has a state, and we're checking the player instance state, and if this state equals to player state dead, which is also a new enumeration, well, this one happens here. Let's zoom in a little bit so that it's easier to read. Yeah, the first time the game over code is run, it runs in this step here, the game over once. So the player input is no one. We disconnect the input now from the player. This is so that we can't move around while being dead, so it would look a little bit strange when you have just a corpse that moves around. And we increase the number of player deaths, which is when the game displays the game over screen, it has a result of 0 to 0 or 0 to 1, or yeah, just the score. And each time you die, it's essentially, if you start over, it's a score for the other team. It's a point for the other team. So okay, it's game over. We don't allow the player to move. We increase the number of player deaths, and for the music, we stop the current music, switch the current music over to music death, and start playing the current music with a priority of 15, and we won't let it loop. Okay, now with each instance of the class enemy, which is pretty self-explanatory because all those zombies are enemies, I'm using here a class now. GameMaker don't really has a sense of being object-oriented in one way, but it kind of is in another way. And you can, for example, make something a class, which means you have a certain hierarchy. So, and I'm using the highest level, a class. So yeah, that I just know that, for example, other objects derive from this one here. So for example, the class enemy is the parent of no object, but has a children, the object enemy A. As you can see, I plan to have some more enemies, but this being a jam game, time ran out. So where were we before? So yeah, with each instance of the class enemy, we set its state to idle. As I said, the player has a state machine, each enemy has a state machine, the game has a state machine, and also, yeah, the enemies have a state machine, and we're switching their state to idle. So if they were attacking the player, once the player is dead and the game is pretty much over, yeah, we're just switching their state back to idle. We will get to this when we get to the enemy, what this actually means. But yeah, I think it's pretty self-explanatory. Okay, so if the instance text notice does not exist. If you recall here in the create event, I said those here, no, where are we? Those three variables here are just slots for certain text blocks. And I elected three different kinds of text: a notice, a result, and a hint. The notice is you died, game over. The result is just the score, 0 by 1 or 0, 0 or anything. And the hint is just something that says, yeah, press F5 to restart. So, okay, so if the notice does not exist, I will create a local variable that is go. I think go is for game object in this case, but it's just something that I can refer to it and yeah, just create something so that, I mean, you can also, by the way, you can also create an instance on a layer, an object text. In this case, it means I'm creating an instance at the layer, object text at the position of the game control, which is essentially, I'm not using a certain position here, so it could be anything on the layer that is called LRUI. As you can see here, the room needs to have an instance layer that is called LRUI, and it creates an object text. If I'm not using this go equals to, this will instantiate this object, but then it's just gone. But I still want to access it and set some variables. And this is, as I mentioned before, why, by the way, why I'm using this doInit flag. So now that I've created the text object here, I can demonstrate it now here. So I'm going to create this text object here, which is an obj text. In my case, this is under effects. Let's have a look at this one here. So once you create an object text, it creates a lot of, it initializes a lot of variables here. And so this happens, this code there here gets executed once this is created here. Now the text events create event, the text objects create event, sorry, has been run. The code execution continues here. And now, when we go back to the text object, so we're in a way right between create and step. So in the text object at the point there in the code above, the create event has successfully run. We're in a way down here, but not in the step event. And as you can see here is do init and do destroy. And then it says center, get the center width, the middle, and so on. So when we are here in this do init block, this instance can already work with the values we provided here. And this is why I'm doing this do init stuff here. So we say the content, which is essentially the line of text that's to this displayed, is just game over. I'm having a lifetime value, which is, again, I'm not using delta time or anything. I'm just using the room speed, which means 60, because of 60 frames per second. So for 3 seconds, the text game over will live. We're doing a text shadow, which is just the text offset in black, just a few pixels behind it. The text position, I'm also using there an enumeration, and MC means middle center. So this is dead center in the screen. I'm not setting any coordinates or anything else, because my text object, if we want to look at it later, my text object asks the current view, the current camera, hey, how big is the view, how wide, how far, and calculates whatever middle center means for the current view. So we're just saying we want the text in the middle center, and the text object pretty much takes care of this itself. As a font, I'm using just 2 fonts here, font medium and font big, so I'm just supplying a font here. And the offset Y is -100, which means once this text gets set in dead center, let's open here. I have here Paint, just for some drawing stuff. And I'm holding my drawing stylus here in my hands for half an hour now, or even longer. So just to show you what's happening here. So this is the view here, and this is the coordinate for dead center. And now I'm just supplying the offset of -100, so which means we're moving the text up towards here, and this is the text box, so that it's not entirely in the middle. Why not? Because in the middle is usually the player. When they died or when they won, but I don't want the text of you won, you lose, game over, or anything to be on top of the player, because this is where you're looking at, and it can be a little bit distracting, or you just want to see what happened to you the moment you died. So this is why I'm offsetting the text here by -100. So then we're creating the text notice. As you can see, this one here, I'm not using this Go instance anywhere else. So we're just creating here an object, but then forgetting the handle to it in a way. So yeah, game jam rules or game jam effects is not very thought through. So usually I would have assigned this to text notice or anything, but apparently I didn't. Instead, I created a text notice which the handle to which we will remember. And this is also essentially the same here. We're creating a new text object on the layer UI, and this time the content is press F5 to restart. Line break, press escape to quit. Yeah, the lifetime is -1, which means that it's not going to die unless we instruct it to. And do shadow is true. Like I said before, it's just an offset of the same text in black. And the position is BC, which means bottom center. And which is also nice in the text object. When we take a look at it, bottom doesn't mean it's straight there on the bottom, because this looks just horrible when you have some text that's just really they're stuck to the bottom, literally to the bottom. Instead, my text object, if you say something like top center or top left, there's always a little bit of a border around it, just that it looks like looks nice and correct in a way. So if you say something for my text object that you wanted a line to be on the bottom center, it's not there on the bottom, but on this invisible inside this invisible rectangle here. Okay, so this is the first time when game over is triggered, and then we switch the game state to game over. And you can see here the victory state, in this case, flips over or goes over, transitions over right to the game over screen. So the difference between victory and game over is essentially just the first step that runs. Here in the game over, it says music is the set, game over music, and it writes game over. And if you have a victory condition, it also takes away the control from the player. It also sets the player to idle, but increases the stat of the number of player the times the player won, plays the victory music as current music, and with all the enemy classes, they set it to idle, set that do destroy, drop loot. We don't want any of the enemies to drop loot. We want to destroy it with effects, which means with this nice little glow, but it shouldn't play a sound because we're already playing the music here, so that it's not interfering there. And then for each enemy, we set the flag do destroy to true. So it means once we've won, all the enemies will destroy itself and won't drop any items, but will look nice. And we display the text notice, goal, and your team scored, press F5, and the state is victory. And the victory is same as the game over screen. So once this initial step here has run, it's the same for everything, either if you won or not. You can press F5 again, hard-coded keyboard presses here. Oh my god, I was pretty pretty hard pressed to just finish on time. So yeah, if you press F5, do restart level is true, as we've seen before. This is this little block that gets executed here. Do restart is 5, and if not instance exists text result, then we say, and of course the result, the text instance of result does not exist because we only created here this text notice and this go game object variable, which we forgot, and also here in the victory condition, which only created a text notice. So once we're here, we know that the text result does not exist. And since this game over is this state just keeps on repeating each step until we restart the level or something, this will only create the text once. So always make sure that when you're creating a new object that it doesn't happen each step. So it will create once, and this game time here is just a local variable which we're only going to need here. And we're rounding the number of game steps divided by the room speed. So the room speed, if you recall, is 60, and each step we increase the game step, so which means, yeah, it's just the seconds, and we round it to the nearest integer. So the result is a new text object, like before, and the result is this. Let's just take this variable here, which is the player wins, and make a string out of it. Add this little colon sign here, and the number of player deaths. So it displays your wins, colon your deaths, and plus, let's continue on this side, new line, and it says the time, game time in seconds. So yeah, this is pretty straightforward. The lifetime of this text display is also until we destroy it. The font is the big font. Let's have a shadow so that it reads against any background, and it is top center. So, of course, it is here. Like 1, 2, 0 for player. Yeah, and that's pretty much what happens here in the game control. So once we're for example, we've just were lucky and victorious, or we were really bad and lost, the only thing we're allowed to do is hitting F5. And once F5 is hit, it's do level restart. We destroy all those text objects we created here. Well, not so much destroyed, just set its lifetime to half a second so that it fades out, which I thought is quite nice. So it doesn't get destroyed instantly, just they all fade out. And do init, which means we are going to run also this do init here, so that the global input, our input is again the global input. I don't know why, but I just wanted probably to make sure that when we're restarting the level, that all the initialization just gets run. But apparently in this case, it's, yeah, we could do without. Again, I'm correcting now my code while I'm explaining it. This is usually the best way, yeah, to find stuff in your code that doesn't make any sense if you explain it to someone. Okay, so we reset the number of game steps to 0. Of course, we're restarting a new game. We're restarting the room because we're pretty sure we're in the game room. and set the game to running first, and this concludes the restart level. So, and once again, we're here in, where is it? Where is it? Running first. Yeah, here we make sure that we are actually in the room game, and then everything happens all over again. So this was it here pretty much for the game control. And the rest of the game happens here with the objects of the player, the ball, the enemy, and to a certain extent the collider and the goal. And of course, yeah, we have a class that's an obstacle collider. And yeah, let's have a look at those in the next chapter of this code review. So now that we've seen how the game is structured in terms of the game control, let's look at the individual components and start here with the player. It consists here of a create event, a step event, and a draw event, and which is, and something that's unusual for me is that I'm assigning a sprite here manually in the editor and not in the code. In my talk about my personal way of setting up projects in GameMaker, I'm usually assigning all the sprites and sub-images and do the sprite drawing myself, but this time I didn't. Why? Well, two explanations. Explanation number one is time constraints. Of course, you can write sprite equals and then you write your sprite name, and this is fine and dandy if you have all the time in the world, but usually you don't, especially not during a jam. And the other thing is, when you do this via code, you also need to assign the sprite mask for collisions manually. And since, yeah, I was pretty sure that I wasn't going to change anything there, I might as well just use the sprite. After all, this is just a prototype, and you would do things differently in the final product. So, but let's not get concerned with that. We will get to collisions in a bit, I assume, and you will probably see how strangely I set things up here for the player. But yeah, we will get to it when we get there. So first, let's have a look at the create event. Zooming in here a little. Good. Again, in the create event, I'm just setting up my variables and all those that I need. Give the script a name, as I mentioned before, for purposes of debugging. And we assign here the input from the global input. As you recall, the global input gets set there in the initialization script. So this should always exist. By the way, all those game controls and so on. But this one here, the game control is set to persistent. The input control is set to persistent. You don't know how many bugs I had by just unticking this box here, and then I was pretty sure that the input control was existing, but as soon as I created it in the init event, in the init room, and then switched rooms to the title menu, the input control was gone, and I didn't understand where and why. And yeah, so yeah, just a reminder to always set, if for your big controllers, for your persistent controllers, you just need to set that box. Okay, back to the player. So the player now has an input control, and again, I'm using an enumerate for the player state. And the states of the player is normal, which means, just normal. Couldn't come up with a better word. Hit, invincible, dead, and idle. So the first state we're starting the player in is the player state normal. So we want to make sure that the player is in front of pretty much anything. Okay, so I'm starting now here with an array. And I initialize my array like this. I'm starting with a local variable that I set to -1. So I'm just using this pre-increment here so that, for example, if I'm having a lot of different kinds of sounds in my array here, I don't have to manually say 0, 1, 2, 3. So I can order them like I want, for example, if I want, just an example, player sound damage to be here on the second entry, I can just move things around, and because it's ++I don't have to change things. This is how I set up my arrays, but as you can see, this is an array with just one entry. Apparently I ran out of time. So the player only makes one noise when they're damaged, so this doesn't need to be an array. Moving on, the player also has some stats, and because the items can change the player's stats. For example, they can change their max health or their speed. So I'm always starting with some initial values so that I can reset it or say, yeah, the maximum health is twice as big, for example, as the player starts out with. So I'm always using this init here. So the health max init is 100, just an arbitrary number, but 100%, why not? Just tinkered here a little bit with the movement speed init and the running multi init. So running multi is just a multiplicator. So if you hold down space to run, then your character will move twice as fast. So this is the 2.0. Diagonal movement multi. As you probably know, if you code some top-down movement and you say, yeah, if the player moves up, then it's just get y minus a certain speed value. And if you move left, then it's x minus a certain speed value. And if player moving up and left, then they're suddenly diagonally, they're moving a little bit faster. Actually, a lot faster. It's noticeable. And this is diagonal movement multi. So once it is detected that the player is holding down two direction buttons, it will just be limited by this, which essentially means that the player speed remains the same as if they're moving just in the cardinal directions. Okay, force dribble init and force kick init. I'm not forcing anything. This is the physical force in a way, but of course it's not a complete physics implementation. It's just I'm calling it force. And the dribble, the force of dribbling, which means if you're just running against the ball and the ball gets kicked a little, is the movement speed times 1.1. So it's not, yeah, you're just kicking the ball a little away from you. If this one was here below 0, like below 1, like 0.9, then you wouldn't kick the ball and it would just stick in front of you. And so you just give it a little kick. I even made there a comment should be greater than movement speed. So this is why I'm multiplying it with 1 by 1.1. So the force kick in it is if you run into the ball while holding down the spacebar, which means you're going to kick the ball. That is the running multi in it. And this means you're going to kick the ball twice as hard. Movement speed in it times 2. Yeah. So I'm just making this here myself. Just a note to myself, so what this value actually is. Stamina drain in it is pretty self-explanatory. So when you're holding the spacebar down, each step, your stamina gets drowned by 15 divided by 60, which is the room speed. The stamina max is, of course, 100, because why not? It's 100%, so this is initial value. And the recover rate is half the drain rate if you're standing still. If you're still moving, it is a quarter of the drain rate. So that because if your stamina would recover as fast as you drain it, you can just keep it as it is. So yeah, pretty self-explanatory. So we also have a cooldown, which is the hit cooldown in it. What does this mean? This is apparently 4 seconds. No, it is 4 steps. Like I said before, I should be using delta time, but I'm just using game steps. So yeah, I'm not using any kind of time base. I'm using steps of the game. And the hit cooldown in it is 4. And I made a very handy comment here, and it is the flashing frame after getting hit. So you're flashing for 4 frames after you're getting hit. So this is a kind of visual feedback so that the players know that they were hit. Invincibility after hit. So you are invincible after you get hit for half a second, which is helpful because otherwise, yeah, the zombies, if they're just 1 frame apart, or you just attracted like 4 zombies and they're just 1 frame apart with their hitting animation or their hitting state, yeah, then they will just pummel you to death. And this is why after once you got hit, you are invincible for half a second. Good. The appearance is the sprite in it is the player sprite. Sprite player dead is player dead. Again, I said I'm not assigning them by code. Well, here I'm doing exactly this, but since I assigned this sprite here in the editor, it also means that I also assigned the collision mask. And as for the player, this is how I started here with the player. I'm rolling collisions myself, not letting GameMaker do this. Usually I'm just using rectangle collisions because they're pretty fast. But yeah, it takes a while to code up and to implement. Is a little bit hairy at times, and this is why I think I switched halfway through my implementation to just rely on the game maker collision masks, which we'll get to when we get there. Just so you know, this is the player sprite. This is horribly animated by yours truly in the finest MS Paint style. Yeah, I'm not too happy with it, but at least you can, at least if you employ a lot of imagination, it looks like a guy from the top walking. So, and this is their collision mask. It's just a rectangle, but this is fine. So but this one here, I don't have to draw myself. I can, just draw it here in the editor, or just have it like here. It is assigned automatically. So this just is an aside. Yeah. We're assigning the player here, and the player dead. I didn't show you this. This is the sprite of the player dead. So it's a different sprite, but it has here its point of origin here in the middle. Good. So once with the player is dead, we switch the sprite from the initial sprite to the sprite that is player dead. The image initial, which is the sub-image of the animation, which means 0, which is the first image. Scale init is the scale of the sprite. It is 1. The rotation is the right. This is also where I'm rolling just my directions, because as I mentioned in my my way of setting up GameMaker projects, still to this day I confuse what is right. I think it's 0 and 90 means down and 180 means left. And I never get this quite right, and I don't recall it. So this is why I just set up. Let's have a look here in the input control. There we go. In the create event, exactly, there's stir up is 0, okay, left is 90, down is 180. I said it wrong before. So apparently this is the direction, and since I'm just using cardinal directions in a way, it is fine that I don't have to bother with angles and such, because we can move only in 8 directions, even when you're playing on the gamepad with an analog stick. So the color in it is white, which means it gets multiplied by white, so the sprite just retains its color, and the alpha is 1, which means it is 100% opaque, apart from, of course, what's transparent in the sprite, but it's not so halfway transparent. And the hit cooldown in it is 5. We have here hit cooldown into 4, and then again here we set it to 5, so either this one should be 5, like this, and we can delete this one here. Good. Cleaning up my code after effect. This is good. Now here we have health and stamina bars. Health bar offset Y and stamina bar offset Y and max width and bar height and so on. This is for the display of the health bars. So let's assume, or let's make it here a little bit stronger. So let's assume this is our player character here in the game. And of course they need a health bar. Let's make this smaller. And their origin, let's make this yellow. Their origin is here in the middle. So this means the offset for the health bar is -40. So we're going -40 up. Okay, I shouldn't have picked yellow. Let's pick gray here. -40. And this is where the health bar starts. And -50, that's 10 more, is where the stamina bar starts. And the bar max width is 60, which means it's 60 pixels. I think when we get to the draw event, I think it's on either side 60 pixels. And also for the stamina bar, and the height, of course, is the bar height. The color for health is red, and the color for stamina is green. This will be used there in the draw event, just so that you know what this is referring to. And of course, we have a lot of flags for the player. Do init, like I said. The initialization that happens here and there is a little bit of more going on than for the game control. Is the player moving? Is the movement horizontal and it is vertical? I think this will be used to determine whether the player is moving diagonally, but we will get there. And if the player is running, initially it is false. So we have here a few process variables. F-init appearance, and since I'm using a lot of reusing a lot of code, apparently I made a script out of it. So let's have a look at this F-init appearance. So the sprite is the sprite init, the image is the image init, scale is scale init, rotation, and so on. So it just saves me a whole lot of typing, because this is what you usually do. You just assign here now your initialization values, and then you said, yeah, the current value is the init value, and this appears, this happens here because the ball and the enemy have pretty much the same setup. Since they have pretty much the same setup, I can just use a script here. And because I'm calling this script here in the object's create event, it means that sprite, image, scale, those variables don't exist here, but it is okay. They are not uninitialized, because when I'm calling the script here, it is as if I just copy pasted it in here. So these variable names will be created here. X new and Y new, yeah, this is for movement, we will get there. The ball collider, no one, we will get to this in a bit. Take damage is 0 or false, or because I'm using this both as a flag and as a variable. So later when we will see if take damage is anything but 0, apparently the player is taking damage and we need to take care of it. Damage multi is how much damage the damage is multiplied with for the player. It's, I think throughout the game it is just 1. I wanted to have some items that make it give you a little bit of more armor, and this would just decrease this multi-value here. Health max is of course health max init, the current health, but yeah, I'm using just the built-in variables here, and I will also use them for speed. We will get to this when we get to the ball physics, well, physics, quote unquote. Yeah, but just suffice it to say, usually I would have called it health current a couple of years ago, or still 1 year ago. But right now, I'm fine that this is the built-in variable. So the stamina max is the stamina max init, the stamina is the stamina max, and so on. Yeah, it's pretty much just your basic assignments here, just to initialize things. Recovery rate, multi, drain multi, movement speed, and so forth, and so forth. Hit cooldown, the ball object is no one, since we don't have a ball associated right now, and the distance from the ball, this is maybe pretty interesting. I'm tracking how far the player is away from the ball, because, oh my god, this is a terrible ball. I should draw it here with my stylus. Okay, this looks more interesting. The distance from the player from the ball. What I wanted was initially an idea that you have to be close to the ball, but not all the time, because the ball is dangerous itself. It might eat you or something. So this was why I was tracking the distance from the ball, but it's not used. Okay, this was the whole initialization of the player. So when the player here, the first time the step event is run, we will continue with initialization, and let's have a look at this. If instance input does not exist, if you recall here, the first thing we do is we assign what we know as the global input variable, which is the input control here, to this variable here. We check if it doesn't exist, just to be sure. And then we will try again to fetch it here from the global variable. And if it still doesn't exist, we will just throw a warning and say, warning, no input control for player found. Just to know, yeah, there's something wrong with the input and there's probably an error somewhere. It's just like an assertion that we just want to make sure, yeah, the player does have an input. Because as you recall from before, from the game control, once the player finishes the game, either successfully or unsuccessfully, we take away the control from the player. And then we reset the level. And this is just to make sure that once we reset the level, that the player has, again, the person playing the game has the control over this player character again. Okay, so the ball object is, let's find the instance, the first instance, the 0th instance, always starting from 0, of the ball object. And since we only have one ball, it will return the first one. So we know what the ball is. Now we create a ball collider. What the hell is this? As you mentioned before, I said, yeah, I'm not trusting the built-in, or rather, I'm not using the built-in collision masks. And this is why I created this ball collider here, which is a separate object, which maybe we should look at it right now. This one here is the object collider. It's pretty much invisible, but it has a create, a step, and a draw GUI event here. So this is pretty pretty sophisticated, or pretty verbose for an invisible object. Well, what does it do? It does pretty much what it says. So if we have here the player again, I'm creating here an instance. It looks like this.
I think it is a square, or I don't think it looks pretty much like this. So it's just in front of the player. This is the thing, the actual collision where the player collides with the ball, or rather the ball collides with the player. Why? Why did I do this? Well, at first I thought I wanted to have the graphics like this, so that the player looks like this and everything looks like it was slightly slanted from the side. And of course, it wouldn't make sense if the ball would hit the player here on the head and would bounce off like so. So I only wanted the collision to happen in this here, in this area here. But then I decided, yeah, let's make it a proper top-down, and yeah, but I'm still using this collider, I think, to some extent. So yeah, this was the rationale behind it. Let's delete it and have a look at what it does. So pretty much I'm creating here the ball collider, and yeah, just create it here at the player's coordinates and create this object collider, which is this one here. So once this code is here, which means once this gets called, once this code executes, it creates this object here and runs the create event, which does check for collisions with no one. Okay, so currently we're not checking for collisions with anything. And is it pixel perfect? False. Okay, I'm leaving out here the appearance. It's just an empty comment because it doesn't have any appearance. And of course, we're setting the flags of doing debugging and initialization. And process variables, the parent is currently no one with height, offset x and y. And the collision coordinates is an array, which is just the coordinates that we will give here. We will set this later here in the step event, but I'm just setting up here an array with 4 entries with 0 and has collision with no one. So check for collisions with no one and has collisions with no one. Yeah, again, I'm just setting up that the variable names that I have them here. So, and this code is completed there. Then we continue here, and it says, okay, the parent is ID. So when the first time the step event runs here and of the do init, we already have a parent. If you see here, the parent is set to no one, so this code runs. Then we continue here and set the parent to ID, which is, if we are here in the player object, so the parent of the collider is the player. And the offset x and offset y and width and height, just to reiterate things, this is the player facing, this is the nose, by the way, so they're facing in this direction here. And we're creating from the player center here, offset x is minus 24 is like 24 into this direction, and y 32, so it's like this, it's like here, this one here. And then we just drawing the width of 40 pixels and the height of 60 pixels, something like this. It's probably, it's probably more like this. and we tell the collider to check for collisions with the object ball. And we even said here if we want to do some debugging and just pass it the global variable. It's not, I don't think why this is useful, but apparently I did it. And it should be pixel perfect because the ball is round, and we want really to check for the roundness of the ball and not for the bounding box of the ball, because at least I want to have some semblance of physicality. Okay, so this is the collider. We're back in the collider. So we're just setting up this collider here, and the collider, if we have a look at the collider, if its parent doesn't exist anymore, such as the player, then it destroys itself, and exit means that it doesn't run the rest of this event here. It just exits and just destroys itself, because this instance destroy only gets executed after the current step event. So this is why I'm exiting this event here. And if we're doing some do init, then nothing happens, so we can actually delete this one here. But let's leave it in because it's in the source, but it doesn't do anything. And here, every frame, we're checking for if check collisions with no one, then we just skip. But we said check for collisions with object ball. So this is not no one, so we're not exiting here, so we continue. So its coordinates, x and y coordinates, we take from the parent. And if you recall here, in the create event, we created this array here with the collision coordinates. Yeah, this is just an array that essentially just defines here this bounding box. So in each frame, it takes the position of the parent, and then from this position, it just 1, 2, 3, 4. Yeah, just takes these edges or coordinates for the corners and still just sticks them into this array. First, we clear if there's already collision happening. We just clear this variable and set it to no1, and then we check for a collision inside this rectangle here with the object ball. And of course, we want it to be pixel perfect. And if there is a collision, then this one has the object ID of the ball, of the object it collides with. Actually, it's the instance ID, not the object ID. And so if 0, apparently this is if do global debug, so I set this to 0, so this one doesn't get run. I recall this, so I could just tweak this hitbox here. And I think in the draw GUI event, it would just print me out, if global to debug, it would just print me out the coordinates of this hitbox, just so I could position it. And this is pretty much the step event. So in the draw event, also if there is debug, then just change the draw color and print out if there is a collision, and then change the color. It was just for debugging, where the rectangle would be drawn and change its color. So just knew, the collisions are working. But the magic, quote unquote, happens here. It just checks for a collision, and once it has a collision, the player will check if its collider, this thing here, has a collision with the ball. So again, it's not the player checking itself, but the player creates an invisible instance of an object, which is just a collision box that checks for collision with a certain object, and we set it to check for collisions with the ball. So this happens here in the initialization. And once this is initialized, as we have seen, the collider itself will follow the player and manage their offset and so on and so forth. Okay, movement, top-down movement is not too hard. So if we have an input, because like you remember before, like I said, when the game is over, we take the input away from the player. So we will only, of course, accept input if the input variable, which is a reference to the input singleton, the input control. If it exists, then we allow movement. So first we said movement is false. And also we say a vertical movement and horizontal movement is false. There is no movement at all. So let's check it and change these booleans if there should be any changes. So if input move is up or input move is down, well, then then there is vertical movement. We're not checking anything else. We're just saying, there is vertical movement, and the same for if move left or right, then we know there is horizontal movement. We will need this just in a bit when we're checking for diagonal movement. But so far for now, this is just checking the direction of the current movement. So the next block checks for is running. If in the input, the interact 1 button is true, which means on a gamepad, the player holds the X button, or on the keyboard, they hold the space bar, then this is true, and the following block will run. So if stamina is bigger than the stamina drain times the stamina drain multi, which as we've here seen in the create event, the stamina drain multi init, where do we have it, is of a certain value, and the multi is just 1. So if the stamina is bigger than the drain factor and times the multiplicator, then we allow running. If not, then we assume there is no stamina left and set the stamina to 0 so that it doesn't get negative or something. So we'll use here a local variable that is the current movement speed, and the current movement speed is the movement speed times the movement speed multi. And if we're running, then this whole thing here gets multiplied with the multi-running. So there's no different speed for running. The running speed is just a multiplication of the normal movement speed, which happens here. Okay, recall here we checked for a vertical and horizontal movement. This is where we're going to need it and take a close look at it. So if movement is horizontal and vertical movement, well, then we know it's diagonal movement. I shouldn't highlight this because it's even worse to read, so I'm just zooming it in. So then we knew the movement is diagonal, and this is what happens here with this diagonal movement multi. We just take 1/3 of the speed, which fixes things. So, and now we look at the actual direction. So if the input and we're moving up, then the y is, of course, the y coordinate nu is the y coordinate minus the current movement speed, which we defined here just before. If the input is down, then we add it to the y coordinate, very straightforward. And with each time we say is moving true. So yes, there is movement. Same thing for left and right, just on the x coordinate. And if we are moving, we set the rotation. This is the direction we're moving in, and we need this rotation to know in what direction to turn the sprite, so that the player is always facing in the direction they're walking. And to get the direction, we just find the direction of the previous coordinates before we process the movement. Here is x is new and y new is just the current coordinates. And then here in the movement, x new and y new is the new coordinate. So the old coordinate, let's say, is here, and the new coordinates are here. Then we just get this direction here, and I think according to GameMaker, where this is 0 and this is 90, the direction of the player facing would be 45. And this is what happens here. And if is running, so we're moving, and if we're running, then we subtract the stamina. By the way, we only allow running if the stamina is bigger than the stamina drained by the multi. So it's not just that we can run even if the stamina is just a tiny little bit, because this is what happened the first time. The stamina, of course, would refill and recharge and yeah, just refill. But if it's not 0, then I would allow the player to run. So you were never running out of stamina because you never hit 0, because it was always just a fraction above 0. This is why I'm checking this one here, that the current stamina must be bigger than the stamina drain times the current stamina multi. And if it's not, we're just setting the stamina to 0. And so if we're running, the stamina is the stamina minus the stamina drain times the stamina multi. And if it is below 0, then it is 0, so no negative values here. So this is for the movement. But what if the player is dead? Well, if the player is not dead, the player should recover stamina. Otherwise, of course, when you would die, the stamina bars would magically fill up, and this would break a little bit. And this is why I said, yeah, we only recover the stamina, of course, when the player is still alive. So if the player is not moving, then the stamina recharges by the stamina recover multi rate. And if they are moving, then it's half the recover multi, because yeah, we're running around. And if the stamina is bigger than the stamina max, well, stamina is stamina max, so we can't overshoot. Collisions, this is good. And I've never coded up proper collisions, and I don't think that this is the right way to do things, but it worked well enough for me. So collisions, obstacle. Collision, so this call here should hold, this variable should hold the instance of any collision. So we place now here ourselves with the new x and the new y, which we still haven't assigned. So like I said before, this was the old x and this is the new coordinates. So we're just processing the movement, but we still haven't moved the player because we still need to check for collisions. So the player is still here, but the following code says, let's assume the player is here on this new coordinate. Are there any collisions? So, and we're just placing ourselves here and see if we are colliding with the class obstacle collider, which we'll take a look at in a moment. So if we have a collision here and the collision is not no one, which means we are colliding and we are inside of something. So let's draw this very nicely. So let's have here, let's draw here the player character. This is the player character, and they just have a high movement speed and moved into this direction here. And this is, for example, here, this is their origin, and this is x and y. And the new x and the new y should be in here. So this is xn and yn for new. So the player should be like this. And now we're checking for the collisions of the player that is actually pretty much stuck in this one here. And what do? We move away one by one. We move them around here in this while loop. And by just the new minus the previous x, so we're just moving then, okay, a little bit around like the previous X and see if they're still colliding. And if they're still colliding, then we move them out from the previous X again. So we're just moving it in the direction from the previous frame. I think this is what this is doing. And each time, after each time we just nudge the player a little bit back in the previous direction, we check if there is still a collision going on. And if there's no collision going on, like this one here, then we can say, yep, this should be the new coordinates which are accounted for any collisions. Animation, or in this case, animationo, running out of time, and yeah, there was no intention to proofread or correct my comments. So if we are moving, then the image is the image index. What is image index? Well, it is just the current ZAP image here in an animation. And we can say here the animation speed is 15 frames per second. Usually, like I mentioned, again, in my how I set up my GameMaker projects, usually I take care of animations myself, but this time I thought, yeah, screw it, I don't have time for this. So my image just takes the image index and the image speed is 0.7. So this is also a multiplicator, so it's 0.7 of 15 frames per second. And if we are running, it is 1.1 times 15 frames per second. I just tweaked around these values so that they look nice and look like the player, if they're walking, their animation gets played a little bit slower than if they are running. And else means the player is not moving, and the image that's going to display it is not this image here from the animation here. Because you have to know, this one is just looping all the time, unless you set it to a certain frame. And when the player is not moving, I'm forcing it to just repeat frame 0, which is this frame here of the player not moving. So yeah, just some GameMaker specific stuff here. So, and once all of this is done, we finally can assign the new coordinates, which we have here from X new and Y new. Good. This was for the player colliding with any obstacles. And I promised you to have a look at this class obstacle collider, which we were checking here. And this is this beautiful thing here. And it has a create event that, yeah, just says width, height, offset and stuff, which I don't really use. We're just drawing here a fdebug box. What the hell does this do? Yeah, it just draws a rectangle from the bounding box of this instance. So if debugging is on, I'm drawing bounding boxes. The class collider is only used here. Those are those pink boxes here. So those are all the colliders. Okay, so those were the collisions. This is the animation like we've had before, and here we kick the ball. So if the ball collider exists, which was just like I said, this invisible box object that's only concerned with colliders, then we check if the ball collider has a collision with no one. If it has not a collision with no one, double negative, it means there is a collision going on with something. And we said in the initialization, we want to check for collisions with the object ball. So now we know, okay, it has a collision with a ball going on. Okay, let's stick the instance ID of this ball into this local variable. So this is the variable of ball collider has collision with. Okay. Get direction. Now we get the direction of the ball, which is the point direction of us, which is the player. Again here, just to make things very clear. Oh my God. Oh, okay, so this is here. This is our origin, and this is the ball origin, and we just get this direction here. So we know at what direction the player is facing the ball. And now we know the direction towards the ball. We calculate the force with which to hit it. Was this English? Well, sufficiently, I hope. So the force is the force dribble times the force dribble multi, as we had here in the create event. As you can see here, force dribble init is the force is movement speed times 1 times 0.1, so we just kick it a little bit. But if we are running, then we are kicking it really hard. It's not dribbling, it is kicking. It's here, kick in it. And when we are running, then the force is not the force dribble, but the force kick times the force kick multi. And Also, when we're running, we are playing a sound, and the sound is kick 1. And if the sound of kick 1 is not playing, then we play the sound. So otherwise, it would, for sometimes you would like collide with the ball in 3 successive frames, and then, yeah, it would sound a little bit odd and has this metallic echoey effect going on. So we're only playing the sound if the sound of kicking is not currently playing. And then what we do here, now that we've pretty much calculated the force with which we hit the ball, then we give the ball this force. And we will know what this means there once we look at the ball object. But for now, yeah, we're just saying, hey ball, we have a collision with you, and we're giving you this force. So we're calculating the direction from the ball towards the player. This is this direction here. And then once we know how hard we're kicking the ball, we will give the ball instance here a force. So now that we have a direction, which we should use an arrow here, like a vector. So now the ball here has a direction and it has a force, which means it is just a vector, so we know how to kick it away. But yeah, again, so once the ball has a force and a direction, it will go into this direction, which we'll cover when we get to the ball object. Okay, so this was the player. We took care of the player's movement, of any collisions, and if they are hitting the ball. What happens when we are colliding with an item? So the item is, we check the player against any object of the class item. So yeah, if the item is no one, it means we are not colliding with an item. What is an item? An item is pretty much any kind of health up or stamina up or anything like this. Those are all enemies. Let me just see if I can find another health pack. Yeah, for example. So those are the items. And the item also is a class here and has just a couple of subclasses for medkit, stamina, max health up, and so on. We will get to this in a bit, but I'm just concerned here with the class because all those here are derived from it. And when I'm checking with the parent, which means, yeah, the class, then of course I'm automatically checking against all the children. So if there is no collision happening, which means we are colliding with an item, and now, yeah, I'm just initializing this local variable here with a value of 0. Now we're switching the type of the item. So also the item itself has a type. And for example, here we check if the item is a medkit. Usually you shouldn't be checking what type the item is, because now we have to hard code, which I did, the item types here in the player character and the item. So this is probably not the best design in terms of code design, but yeah, for a jam game it works. So I'm checking, okay, is the item type equals the item type item type.medkit. So yeah, it is a medkit. If so, then the health is the health max. No, this doesn't do anything. Okay, let's delete it. I just meant to say I have no idea what this does, and apparently it does nothing. So the value is, we take the item value and just round it. Because the item value could be, for example, something times some kind of fraction or so, but we're only concerned with integers. So the value is just the item's value rounded. Whatever item it is, we just know that it has a value. And we know since it's a medkit, so okay, so the item value, we just increase our health with this value. And if the health is bigger than health max, well, then health is health max. And that's what happens when we walk over a medkit. What happens when we walk over a max health up? Well, also we just take the value, but this time the value means something different. It doesn't mean the health to add, but instead it means the max health gets increased by the value. And so the health also gets increased by this value. So for example, if you have a health bar that goes from 1 to 100, and we're here at health, let's say health 90, and we pick up +5 maximum health, then it would be unfair or it would look strange, because the health bar doesn't scale up. It's always the same length. I meant to change this the more max health you get, so that once your health bar is really long, that you know you have a lot of health, but it doesn't scale visually, but it does, of course, in terms of the values. So when you pick up a health maximum at +5, it means we are at 105. And I'm also giving those +5 to those 90. So since the health bar is always the same length visually, yeah, I don't want that players suddenly get no additional health, which means that for some reason the health bar would look like there's more black than before, because of course now there's a lot more headroom. I hope this makes sense, but yeah, essentially I'm just giving the player also the same amount of health the health max gets. I hope this makes sense. Getting a little bit raspy already. Okay, wrapping things up a little bit, if they walk over the stamina, and stamina is equals stamina max, well, this doesn't do anything. Again, we just check if the stamina is big or exceeds the maximum stamina, and if so, it's the maximum stamina. If it's a stamina up, same thing as with maximum health. And the only thing different here, we have a stamina multi-up, which increases the rate of how fast you regain stamina. And this one just, yeah, is the recover multi plus this one value here. And I think this one looks buggy because since it's a multi, it's a float anyway, and we shouldn't round it to a whole number. This looks a little bit fishy to me. I would check this out if it really does what it should be doing. Okay, so this is what happens when we switch for the item type. So we know there's a collision going on with an item, and we already applied the item's effects, should they apply. Next up, what we do is we create a new text object. Oh, got something again on Twitter, and now I got an email. Okay, so we create here an object text on the layer UI. Just like before in the game object, in the game control object, when we say game over or you won. And what the content is, yeah, the text, the string that's going to display it, and item, this name by string value. Yeah, each item has a name and a value, and essentially this translates to, for example, if you pick up a max health item, its name is max health, and then it would read max health, and now we just concatenating strings, and then it says by, and then we get the value that we extracted here, and also turn it from an integer or a float to a string, and say max health by something. So we said increased max health or something by 15 or so. So this is what this means here. We're just creating this little heads-up display. The room speed is 3 seconds, and the position is bottom center. Yeah, we want to make a new glow effect, and I have here a function that says f effects item pickup and item this color. So each item also has its own color. So for health it's red, for stamina it's green, and I meant something blue but didn't get to it. So yeah, we don't care what the item is. We only know that it has a color, and we give this color to the script that is f effect item pickup. F, I think, was once that I meant it is a function. So let's have a quick look at this script, what it does. And this one here just does the following thing. It shows a debug message 1. Yeah, we won't need this. And the only argument we take here is the argument color. So, and we create here a new object fx glow. This is also a not so small object by itself, but essentially, yeah, it's just an object that does a glow, and we can specify a lot of things. And we just instantiate this object here and say its parent is the ID of the item. Its color is the color we passed. Is it static? No, it is not. I'm sorry, the instance is the ID is of the player, because the player is glowing green when they pick up stamina, or red when they pick up health. So this is for the player, for the visual effect on the player. So scale, it starts, so it's 5 times bigger, and then when it ends, it's 4 times bigger. It's just how its appearance over time. So scale Y and X, and also the alpha. So we start with full, and then it fades out, and the width and the height and the duration is ½ second. And should we kill it with a parent? We say no. So when the parent, in this case the player, dies within this ½ second, then the object would still play its little glowy thing. But if you're interested in this glow object, we can make a whole video on just this glow object. But so yeah, just to reiterate, we check if there's a collision with an item. If so, and we are allowed to pick it up, then we apply the effects of the item, print a little text that says what this item does, make a little color around the player, and play the item's sound. And once all this is done, we destroy the actual item here in game because, yeah, we've picked it up, and this can only happen once. Okay, and lastly, as I said, they all have states, and also the player has different states. When the player starts up, state, there we go. Player state is normal. And the player, yeah, has different states, so let's see what happens when the player is normal. Okay, so this means the player is in game, just like usual, and we're just playing the game. And now in this normal state, we're just checking for a couple of things. For example, does the player take damage? And so once we collide with a zombie, the zombie writes into this player character a certain damage value. And we're checking each frame if take damage is bigger than 0. This is what I said before. This is not so much a Boolean. Take damage. Yeah, this is not so much a Boolean. It is just, yeah, a variable. So if it's not 0, we know this is the amount of damage the player should take. So we change player state from normal to hit and add a glow effect around the player. It's a red glow, so we know, yeah, it's not so good what's happening to the player. Yeah, I'm quite well aware that this is the same color as the health pickup. So yeah, it's not the best solution. It's not very clear that when you're walking over a health pickup, you glow red, and when you're taking damage, you glow red. Yes, it has to do with your health in a way, but the one is good and the other is bad. So yeah, I'm not really too happy with how I solved things here. But yeah, pretty much it's just, yeah, the player will change its state to hit and create this little glow effect around the player. But this is only when, of course, when the player is hit. And the other thing in the normal state is if the ball object exists, which usually it should, we calculate the distance from the ball. This is not used, as I mentioned before, but this happens here in this normal state. So let's head back up to this idle state. What does this mean? Idle means we're taking away the control from the player. So we're saying the player is not moving and the image is 0, which means just the player standing there. So this is the idle state. Just to mention it, because now we're going to look at what happens here now when the player got hit. So if the player got hit, so if this take damage variable is bigger than 0, which means it is, usually when you take hit, it, like I said before, this value gets greater than 0. And yeah, then I'm throwing off a debug message. So I'm just knowing that, okay, the health plus string health is my current health. So that I just know my health, or that I'm being hit here while I was developing it. So of course, the health is the health minus take damage times the damage multi. So take damage is the damage an enemy does to you, and the damage multi, as we've seen, I've initialized to 1. But if you're more vulnerable, this would be bigger than 1. And if you're less vulnerable, for example, you have some kind of armor, then this would be smaller than 1. So yeah, this is why I'm just multiplying it with this one for, yeah, just for the odd case that I would have had some time and made a new item that changes this value. Okay, so we've deducted now here our damage. So let's say, okay, the damage is now 0, because otherwise we would be stuck in this hit run and would just get hit until we die. So this is why we set damage back to 0, because yeah, we've deducted it. Okay, so R is a random number, and this is just a random number of the array length of our damage sounds. As you recall, here, where is it? Where is my cute little array with the damage sounds, which consists of 1 entry? Yeah, I can't find it right now, but this I've meant to have a lot of different hit sounds of and but in the end, yeah, importing sounds in GameMaker, even GameMaker Studio 2 is really a pain, and this is why I just added 1 sound to get the point across. But essentially this means, yeah, let's just pick a random sound here and play this random sound from this array that is sound damage. That's pretty much it. Okay, so if our health now, so we've deducted the hit points, and if our health now is less than 0, well, we're dead. So health is 0, that we're not having any negative values here, and switch the state to player is dead. And this concludes this case here. If the health is not 0, well, then of course this doesn't get run, and it looks like this. And then we have a cooldown. So the hit cooldown, like I said before, that is half a second. So we deduct 1 from the hit cooldown, which hit cooldown in it, so it's 5 steps. So each time we deduct 1 from this hit cooldown. So, and if this one hits here 0 or is less than 0, then we say, okay, we reset this one here to 5 or 5, and say invincibility cooldown is invincibility after hit. So this is also how long are we invincible sorry, after a hit, and we switch the state to we are invincible. And this concludes here once we are hit. Okay, so we got hit, our damage was deducted, and now we are invincible. And this invincible cooldown gets also minus, and this invincibility after hit is the room speed times 0.5. So it's half a second that we are invincible. So this one also we just decrement by 1 each time we are in this state, which means once per frame. So after 15 frames, 30 frames, of course, is half the room speed. Then invincibility cooldown is less or equal to 0, and now we are not invincible anymore, and we switch the state back to normal. But what if we died? Well, then the player's state is dead. And once the player is dead, we switch the sprite from the normal walking sprite to sprite player dead. The image is just the first image, the first sub-image in the sprite. I don't think this is necessary because I don't think there are more than 1 images. No, it's just 1 image here. So yeah, this line of code could also be taken out. And the image speed is 0, which means, we're stopping the animation. And the depth is 110. What does this mean? Usually the player character sorts on top of the enemies, but as soon as you die, I want the zombies to just walk over your sprite because essentially you are lying on the floor. What doesn't happen here is that the control is taken away from the player and the game is notified that the player has died. I don't know why this is not happening here, but I opted to check in the game control. Just have a look at it again. Where are we? Control game. So that each time we're checking in if the game is currently running, we're checking if the player exists and if the player and the state of the player state. And only if the player state is dead, then we take care of the game over stuff and take away the control from the player. Yeah, so this happens in the game control and not in the player control itself. So yeah, the player normal state we had, and this is pretty much everything in the step of the player event. Lastly, the draw event, what happens here? Yeah, we just draw the player sprite at the current, with the current sprite, the current sub-image, at the current coordinates, at the current scale, at the current orientation, the current color, and the current alpha. So yeah, this is just draw self, essentially. But if we have here draw health bars, apparently I implemented this here as a local variable, which doesn't make any sense. Probably I wanted to switch it off or on via global variable, but of course this one here is always true. So if, again, also here in the draw event, we switch the state, I don't think it is good to have a lot of code in the draw event. Usually you're just concerned with drawing things and not a lot of logic, but this would introduce new variables, which you have to create and initialize here, and yada, yada, yada. I'm just doing it here because it's more obvious what's going on. So also here, if the player state is idle, well, then the image is 0, which means, yeah, we're not playing an animation. The player is just on the first frame, which means they're just standing there. Okay, if the player is hit, then we draw the sprite 1, but this one here, look at this. The comment is an arrow with an exclamation mark. This one here. Okay, so what is the sub-image of sprite? Let's have a look at player sprite 1. It is this one here, and it doesn't make any sense. But I need to explain what this does, because the first time I just had the player sprite, which was the first image just rotated, and there was no animation. And I only had one image, another sub-image, and this was one, and this was pretty much just the player in white, so that the player would blink white when they were hit. So this actually doesn't really run. I think this never really happens or doesn't make any sense because, as you've seen before, we create this red glow around the player. So I think I can take this safely out. Also the same with the player is invincible. Nothing happens in the draw event if there's normal. Only when the player is dead, we don't draw the health bars. Okay, now I get it why we set it here. So that we can say draw the health bars always unless they are dead. So, and if we draw the health bars, again, I don't think you should put that much code there in the draw event, but I think since it's only for one instance, this is fine. So what does this all mean? Left X, center X, right X, top X, bottom Y, color, back, color bar, and so on. Draw health bar, draw stamina bar. This is a lot of code for the health bars. Why and what's happening here? Let's draw another little sketch. Essentially, if you draw a health bar in GameMaker, you can say if it goes from left to right or from right to left. This is the background color. It also has an optional border color. And for example, if you say, yeah, it should go from left to right, then you fill it up like this. This is, for example, 50%. This is how health bars work in GameMaker. But you can also say, yeah, you don't want a border. So then there it is. So then it looks something like this. So you don't have a border, but it still goes from left to right. And as you've noticed, if you played my game, it looks like I think it was Diablo, where it just goes from the outside towards the center. And this is why I'm drawing two health bars, one that goes from left to right and one that is actually mirrored and goes from right to left and looks like this. So that in the end, your health bar looks like this. And if this one here reaches 0, which is exactly the middle, so if it gets smaller, it just moves in. So this is why I'm drawing the health bar twice, once into this direction and once into this direction, and it's just here at the middle. And all this code does here is just take care here and takes the bar width max and bar and height offset and so on, and and calculates the top and left and right, and and just this whole boilerplate stuff here of drawing two health bars, one for the health and the other for the stamina. And here we have the debug box, which is also a very short script, which just draws here the bounding box of this instance. So this was just for me as I was debugging the game. And this concludes the object player. So now let's take a closer look here at the enemy class first. So a first thing we will see and notice here is that it is parent to the object enemy A and nothing else. And so I'm assuming we're jumping back and forth between the actual implementation of this class within object enemy and just the overall class description. So as we can see here, we have a create and a draw event, and the actual step implementation, this happens in the individual enemy objects. But there only is one, so this will be pretty self-explanatory. Okay, like anything else here in this game, also the enemy has a class, or a state machine, sorry. The enemy class has a state machine, and it is composed of the states dormant, idle, roaming, pursuit, attack, wait after attack, and pursuit once. I'm setting here the depth to be 100, which is behind the player, and pretty much, just the lowest object visible that comes on top of the background, so that the ball should draw in front and the player should draw in front, and so on. So also, just like with the player character, the enemy has a certain health. Right here, I'm just assigning default values, which should get overwritten here in the enemy base implementation or in the enemy A implementation, but we will get to this. So I'm just providing their default values for health, initial health, movement speed, the aggro multi init, which we'll get to in a bit, and the perception radius, and the ball kick multi and the damage init. Ball kick multi determines just the force if an enemy collides with the ball. Essentially, they are just dribbling it just like the player. And the initial damage there is also set to 10. And we have various kinds of cooldowns. This happens then that we will use in the state machine. There's a cooldown for attacking and roaming. As you can see, min and max for idling. We will see what this means in the state machine. But for now, just be aware that this all gets set here in the class enemy. And the lethal ball speed, this is important because as a player, you can kick the ball, as you've probably noticed when you played the game or just looked at a video of it. And the player can hit the ball with a certain force. And this is the speed of the ball, the game maker speed value of the ball. So when the ball is bigger or equals 3 and hits an enemy and collides with an enemy, then it is lethal for them. And if anything below 3, then the ball will just bounce back. So there's also a loot chance, and this is the one variable that I apparently set here in the init script. So this is the loot chance, as we've seen before. It's just, the overall chance of loot dropping, and it's about 1/3. Then again, we have here some appearance like the initial sprite and the sub-image and scaling and the initial direction and the initial color and alpha. Nothing special there. And of course we have flags. The omnipresent do init flag is here, but also do destroy. And as we've seen before in the victory condition, we can define when we say destroy true, then with the next step, the enemy instance will destroy itself. But we can specify some options. Should we destroy with the loot? False drops loot upon destruction. If I think this when it's true, we can even set a certain kind of we can even force a certain item to drop. Destroy with effects means that it plays a sound, or at least in this case this little glow effect once they die, and destroy with sound, right? Plays a sound upon destruction. I don't know if I've implemented this, but that I have an actual sound, but I have implemented the option to destroy an enemy with sound. And initially the player is not in range. This will be checked in the state machine, which we will get to in the step event. So we have process variables, the movement speed, the aggro multi is of course the aggro init, and damage is damage init, and the initial state is the enemy state roaming. Again, this will we will see what this means in the state machine. Then we have attack cooldown and roaming cooldown. Just the process variables where I'm assigning the initial values to the actual values that are changing, the variable values, if you will. So roaming is walking, is false, and target X and target Y is the position of the once an enemy has spotted a player, it's the position where they assume the player to be. So essentially the place or the coordinates they will move towards too. So, and of course they need to know who the player is in the game, so we will just take a look at the global variable, and it returns the instance ID of the player. And of course we have here this finit appearance script, which just assigns the initial sprite to the sprite, initial sub-image to the image, and so on and so on. So this is why I made it a script, because I'm using it throughout for the player and the enemy. And I think I meant even to use it for the ball. So because this is, I'm essentially, as I've stressed before, it's exactly the same using a script here in the init event as if you just copy and paste this one here. It's exactly the same in terms of GameMaker. So it's kind of like a macro, but not quite. Okay, moving on to the draw event. This is nothing really special. It just draws the current sprite, the current image at the current position, and so on. If we are doing debugging, it draws this debug box, which draws just the bounding box for the collisions. So just for debugging. And just some more. If we're doing if debugging is on, then with a yellow color, we just switch the state of the enemy if it's idle, roaming, in pursuit, and just have a different color so we know what their perception status of the player is. Just for debugging. So if you switch do debug on in the globals, you will see all kinds of heads-up displays. So again, this was the base implementation of the class, and now let's have a look at the specifics in the object enemy A object. So this little icon here means that it's inherited from, if we hover over it, from class enemy. So I'm not doing any changes here, but here in the create event, this means we inherit something, but then we override it. And as you can see, it's pretty clear here. Event inherited means, of course, we inherit what's in this event here, in the create event of the parent object. So it's like just copying all of this here and pasting it instead of this line here. It's exactly the same. So if we want to override certain values, such as, let's say, do destroy, we want to override this one here, we have to write it here again. To destroy is true. If we assign it here in front of the inherited event, it will get overwritten by this one here. So yeah, it's pretty straightforward. So we inherit all what we just saw before in the class definition. Yeah, it's not quite a class. I'm well aware of this. But now we're digging into the specifics of the implementation of this certain enemy, which is just the only enemy that I have. They have a health of 20 as compared to the player, which has a health of 100. The movement speed initially is 1, and the aggro multi in it is 1.5. So once they are aware of the player and yeah, just moving towards it or towards the player, they're moving by 1.5 the speed they had before. And their perception radius is in pixels. Yeah, it's just a radius with them in the center by 350 pixels where they are looking for the player. The lethal ball speed I'm overriding here is now 5, and the ball kick multi is 2. So when they collide with the ball, they will kick it with a force of 2. And the force is nothing a real physical force, it's just the speed value, this one here, the built-in speed value in GameMaker. So again here, I'm writing some kind of array or multiple arrays. So each of those arrays has, it's just composed of 2 entries, the sound when they take damage, the sound when they attack, and the sound when they notice the player. So yeah, at least I have here some variation, but not much. Those are just assignments of the, where do we have them here? These sounds here I recorded. By the way, I recorded way too many sounds. I just went straight for the cake and just recorded a lot of sounds, which then I realized how hard it is or how cumbersome it is to import sounds into GameMaker, so this is why I'm just using the bare minimum. Okay, so now we've filled up the sounds when taking damage and attacking and noticing, and the default damage an enemy makes to the player is 10. So it takes 10 hits to the player when they're not having any kind of special health pickups for them to die. And the attack cooldown in it is the room speed. So when they attack, they take a break of 1 second before they attack again. Otherwise, they would be attacking each frame, and so you just run into a zombie, and after 10 frames, you're dead. So this is not fun, and this is why I've introduced this cooldown here. The actual implementation we will see there in the step event. Okay, the appearance is of course the zombie orange. I drew a default sprite and then I just painted it in. And I thought to have different kinds of zombies. Yeah, just essentially palette swapping them. But yeah, it's just one. So we have the zombie orange. Yeah, the initial sub-image is 0, which means the default pose. Scale is 1, direction is right, and the color gets multiplied by white, so it stays the same. And of course the alpha is completely opaque, apart from the transparent pixels, of course. So yeah, nothing really special here. Let's take a closer look at the step event where all the enemy behavior takes place. So the first thing we check for if do destroy is true. We check this even before the do initialization, because when we create something and with the creation we said it's do destroy to true. Should this ever be the case, there is no need to do some initialization because we want to destroy it anyway. So we're checking for, if do destroy with effects equals true. And if so, we create a new glow instance that is static, has the color orange, has a certain width and height, and starts with an alpha of 0.5 and ends with an alpha of 0. So it just fades out. And the duration is roughly between 1 and 2 seconds, so it doesn't look the same for each zombie, but that's pretty much it. It's just an orange glow, and there's even another orange glow on top of it, so it's 2 of those glow effects, which we can look at the actual game object of glow effects in a later video, or just have a glance over it here. But yeah, it just draws a glow at a certain position we will give here, and can set a number of parameters. So this is just if do destroy with effects equals true. You probably notice that I'm not setting do destroy with effects equals false there at the ending, because we're destroying the instance anyway after this is run, so there's no need for that. Then, of course, do destroy loop drop. And here we're just picking a random number between 0 and 1. And if it is smaller or equals than the loot chance, yeah, then we will create a new item, a new class item on the instances layer in the room. And yeah, just create it on the layer at the position, X and Y position of this instance, which is the enemy. And lastly, if we say do destroy with sound, we're just picking a random integer from 0 to the array length of the sound damage, and then use this there as an index to the array of the sound to be played. So yeah, just pick a random sound from this array. And then we say do destroy is false. I don't know why this is necessary, but actually it isn't. We say instance destroy and exit. So exit, so this means we're stepping out of this event here, and what follows after exit won't get run. So this is once we destroy it, but let's assume we're not going to destroy it as soon as we create it. Instead, we're just running the do init stuff. What we do is init appearance. So again, this script gets run. Why do I do it twice? First in the create event and then here again. Yeah, maybe I thought some factory implementation would change the sprite or the image, so this is why I'm reassigning them here should they be changed. Usually, or in this case, they didn't change, so this is actually not necessary. Yeah, the movement speed is movement speed init, and so on and so on. So yeah, it's just a half-assed reiteration of what we're doing here in the class, in the base class. Where do we have it? Enemy here. Yeah, it's pretty much the same as, yeah, just assigning those process variables again, because yeah, maybe we used a factory and things changed between the create event and the first time the step event ran. Sorry, this was the draw event. Create, step, draw. Yes, this is good. So in the enemy class, we had this roaming cooldown min and roaming cooldown max and idle cooldown min and idle cooldown max. Yeah, and this here just assigns a random value, a random range between minimum and maximum, so that not each zombie takes exactly the same amount of steps to be roaming or to be idling. So yeah, this is essentially it. It's just assigning those process variables in the init stage. So now here we have every frame. And every frame, each instance of the zombie looks for the player, or tries to find a player instance. Apparently, I didn't prove it much, because if the player doesn't exist, for some reason the player instance got destroyed, yeah, each zombie will say, yeah, this is not initialized, we can't find it, it's not possible, and the game will crash. So maybe we should put some safeguards around it, but for now it works. And here we have the state machine. So before we dig into the state machine, let's see how deep this rabbit hole goes. And yeah, almost here towards the end. Yeah, this is the end of switch state. So outside of the state machine are the things that we're going to check for each frame, no matter what state the enemy is in. I don't know if this is a good idea, but this is how I implemented it here. And the first thing is we're checking, independent of state, if there is a collision with the ball. So we assign a possible collision to this object and to this variable call for collision. And if collision is not no one, we're having a collision with the ball object, and since we're only having one ball object, well, it must be the ball object. So, okay, we have a collision with the ball. Let's have a look at the speed of the ball. So if the speed of the ball equals or is greater than the lethal speed, well, killed by ball. So we're saying, yeah, we want to destroy this zombie instance with the effects. It should play a sound, it should drop some loot, and of course, we want to destroy it. So this is all true. And otherwise, when we collide with the ball, when an enemy collides with the ball, but the ball is below the lethal speed, then they kick the ball. So we're just picking here the collision. We're setting the force inside the ball. When we take a look at the ball object, it's a little bit like with the damage of the player. As I recall, the ball object itself, the ball instance, checks for this force variable inside itself each frame. And if it doesn't equal 0, then the ball knows, yeah, it just got kicked. Doesn't matter by whom, it only knows it needs to go in a certain direction with a certain force, and this is what this does. So it takes the speed of the zombie Yeah, this looks fishy to me again. This should not be the speed of the zombie. I think, yeah, this is should I'm assuming this should be call.speed, and so the speed of the ball times the kick multi of the zombie. But yeah, it's right now it's the speed of the zombie, and since they're not moving very fast, it is not very fast. Yeah, just we're assigning this kick speed of the zombie to the ball as force, and the direction is the direction from the ball to the zombie. Let's have a look here in Paint again. So if we have here our zombie, and they just collided with the ball here, and this is the origin of the zombie and the origin of the ball, just like before. It's not really in the middle, but again, yeah, this here is our direction, and we just use this direction here to kick the ball away from the zombie. And we play the audio of the bounce sound. Yeah, sometimes this, because the collision happens multiple frames in succession, this sounds a little bit strange when zombies hit the ball, but it's cool for now. So if this is what happens when zombies collide with the ball, but what if they collide with an obstacle? So you remember those pink sprites there in the room? Well, yeah, they start dithering a little bit, and this is not a class 1 implementation, let's put it that way. Essentially, it is just this. We check for a collision with this obstacle collider, and if there is one, then we flip the direction by 180, so that the zombie, if they're moving into this direction, we will flip, and they will move into this direction here. So this happens on one frame, and the speed of the zombie is the movement speed, their initial movement speed times 2. So for one frame, we're saying, yeah, if you're colliding here with something like this, you should move into this direction for twice as fast as you ran into it, so in order not to get stuck. And the new state is idle, so that if they were in pursuit of the player, they won't continue pursuing through this wall here, at least for one frame. But essentially, yeah, just back out the way they came from in double the speed. Of course, I didn't pay any attention to any fringe cases. I just was happy with how it worked with one collider. But the problem is, if you have here 2 colliders, and suddenly the zombie is now stuck in 2 or 3 colliders, there's always one collider they are stuck in, and then they just start dithering between those 2 directions. So each frame they will change direction and move with double the speed into the different direction, into the other direction. And yeah, this explains the zombie behavior. But yeah, so this was everything in the zombies that was outside of the state machine. So let's have a look at the different zombie states. So the first state we have here is dormant, which means they don't have a speed, they're not moving. The image speed, as you recall, is a multiplier, always say it wrong. Yeah, this is the default frames per second of the animation within the sprite. It just gets multiplied. So it's 0 times 15 frames per second, so we're just stuck here on the first sub-image, which means, yeah, the zombie will just look like the first sub-image in their sprite, like so. So they're just standing there with their stubby arms outwards. This is when they are dormant. As you can see, there's no exit state for being dormant because I don't think this is why I said I have a half-assed state machine implementation. They stay dormant, and the only thing that can change their state once they're dormant needs to be from something external, maybe the game controller or something. So once they are dormant, they just stuck in this. So yeah, just to mind this. The other state we have is idle. So their speed is 0, they're not moving. Their image speed is also 0, so they're again stuck there on the first frame of their animation. And yeah, the image index, which is image 0, is just the first frame. But we are decreasing the value of idle cooldown. And if idle cooldown is less or equals 0, then we pick a new random value of the idle cooldown within the range of minimum and maximum. So this idle cooldown starts again, but we also change the state to roaming. So when they are idle, they're only idle for a certain amount of time. And once this idle cooldown is 0, essentially it's an alarm in GameMaker parlance, then they start to roam. What does roaming mean? Also, the roaming has a cooldown, so they're not endlessly roaming. It's just like with being idle, only for a certain amount of time. So once they are roaming, their image speed of the animation is half the speed. It's like 7.5 frames per second, so they're just slowly moving and shuffling about. And the image is the image index, so yeah, it always plays the sub-image the animation is currently on. So if the roaming cooldown is lower or less than or equals 0, yeah, which means this roaming cooldown ran out, stand still until the next cooldown is over. So if the current roaming is walking, this is something we will set down here, then we give it a random direction from 0 to 360. So it's just a random direction into any direction, and give it a movement speed and the aggro multi in it. So if they're just moving around, then we will just give it a direction and a speed and send them off. But if roaming is not walking, which means they were standing still, I think, I think this is what this does. This is not the most telling Boolean. But so if roaming is not walking, then the state is idle. So essentially, it's just, have they been moving? Have they been just moving around here? So that they always switch between being idle and just standing there and roaming around randomly. So then we switch the state to idle and just set a random number here for this idle cooldown, which also happens here. So I'm just making sure that the idle cooldown is not 0. Then roaming is walking. We just flip this boolean here, and also set here the roaming cooldown. So this is what when the roam is just, this one here is just for the random movement. But next we check if the player exists. Okay, so apparently I'm not checking if the player exists here when we are looking for the player, but I'm checking here when I want to do something with it. So which is fine. So if the player state is not dead, if the player is alive, well, then we get the distance between the zombie and the player. And if this one here equals or is less than perception radius of the zombie, which means the player is in range. So I'm going to draw the player here in black. This is the player here, and the zombie in red. So this is the zombie, and they have a certain radius. Usually it's, if it's like this, of course, then they won't spot the player. But if it's like this, it's always in the center here, the origin is always in the center. Well, now they know that the player is there, and they will start having a target on the player, which happens next. So the target, we get the player X and the player Y. So as long as the player is inside the perception radius of the zombie, the zombie will always move towards the player. But if the player just left this perception radius, the zombie will continue walking towards where the last seen the player, which means the exact coordinates when the player left this radius, this perception radius. Which is, of course, more interesting than as soon as the player would leave the perception radius, they would just stop. So I thought, this to be very nice. So, and once we've spotted the player and got a target of the player, then we switch the state to pursued once. So this is just, again, like with the game state, pursued once means this happens the first time we're into pursuit mode, and then we switch the state to the normal pursuit mode, or default, which happens each frame. So the first step, we're on pursuit mode, it's pursued once, and we're just getting a random value, and we're playing essentially just like before, a random sound within the array of the zombie spotted the player, which is just. So I thought it to be interesting to give the player a feedback, so that they know something has spotted them, and by the number or the intensity of this sound, they know how many zombies they just triggered. So next up, so in this first step, we're only playing the sound, and then we're switching over to regular pursuit mode. So we're in pursuit, so the image speed is 1, so this means now the animation speed of the enemy, of the zombie, is 15 frames per second, and of the current sub-image in the animation is the current sub-image in the animation. I'm just assigning those because in the draw event I'm using now here my own variable, but this could be just image index. Why can't I type? Of course I can't type because this is an inherited event. from the parent class enemy, so this is why I can't change it here. But essentially, if I just used image index instead of image, it would be exactly the same. Yeah, like I said in my GameMaker projects talk, I like to roll my own variables, but yeah, sometimes it's just cool using the built-in variables. Okay. So now that we're in pursuit of the player, well, let's check if we are colliding with the player. So once we are colliding with the player, we can attack them. So if instance exists player, this is good. Okay, now we're checking, we're saving the variables of the current coordinates because we want to do something with them. And now let's see a collision there if we're colliding with the player, actually at the X and Y. I could use X and Y because I'm not changing those local variables here. Anyway, so let's check if we are colliding with the player, and if we are colliding with the player, so first we were in pursuit of the player, now we're colliding with them, well then let's change our state to attack. But if we are in pursuit mode and are not colliding with the player, well then let's get again the distance from the zombie towards the player. So what we're checking for each frame is is the player still within the perception radius? And if it is, we will update the target of where we're moving towards. And if not, well, we're just moving towards the last known target with the speed of the movement speed and the aggro multi, which means, yeah, we're moving at a faster pace than when we're just shuffling about. So let's have first a look here what happens when we attack the player. This is the attack state. And it just says, yeah, we just set the animation to the first frame. Anything else we can ignore. Then the speed, of course, we stop. Now we won't move in a point direction, but we stop. But the direction in which to face towards is, of course, the direction from the origin of the zombie towards the origin of the player. So yeah, essentially the zombie is facing the player when they are attacking them. And here comes the magic line. Player take damage equals damage. So we are assigning the damage of this object, of this instance of the enemy, to the player. And as we've seen before, when the player checks each step, if their take damage value is greater than 0. And if it is so, then the player knows that it has been hit. So this means we've successfully attacked now the player. So we can switch the state to wait after attack, like I said, so that the enemies don't pummel the player to death instantly within a couple of frames. So we've successfully attacked the player. Now let's wait after the attack. The image speed is 1, but the image is 0. So again, we're just waiting there in the default position, the first frame of the animation. And also we have here an attack cooldown. For some reason, this is a post decrement and not a pre-decrement. It should go like this, but yeah, it's just nitpicking here my code. And if this attack cooldown equals or is less than 0, which means this one here has ran out, yeah, we just reset this one here to the initial value, which I think was just 1 second, and we switch the state to roaming. So after we've attacked, within 1 second we are roaming again. And this has been the state machine here for the enemy, because when the player, okay, so we've just attacked the player, bam, and waited 1 second or our cooldown, and then we switch back to roaming. So what happens during roaming mode? Well, we see here if we are within the reach of the player and if it's within our perception. And since the player probably won't get away within 1 second or outside of the radius within 1 second, well, then we move towards the player. Maybe they're still standing there. And once they're still standing there, well, we're in pursuit once. So we're playing on pursuit sound. Okay, now we're in pursuit. The player still exists here, and we're probably already colliding with the player. Then we switch the state to attack. Now we're here in attack, and we can deal out some damage to the player again. So this is a pretty simple state machine, but it works for our enemy. And yeah, this explains also the last line here, explains the strange enemy behavior once they run into obstacles on the map. But yeah, that's in principle our enemy. Now let's have a look at the next object that is important for us, which is the ball, of course. Now the ball object is also set up like the other objects. It has a create, a step, and a draw event, but it's not too complex. So in the create event, we set its depth to 0, so it means it is above the zombies but below the player. And here we have some strange kind of friction. Again, this is not a physical simulation, this is just some random values. And we say the ground friction is 5 divided by 60. So this is the friction per step. So this is essentially what we're deducting from the overall speed each frame. And the bounce friction is when the ball just bounces off something or it just collides with the collider. This is the speed amount we subtract from the overall speed when the ball is bouncing off. So again, I made here a comment, friction per step. Yeah, you shouldn't be doing this. You should have some kind of time-based or milliseconds-based approach. Yeah, again. So, but what is this? Shine in it and glow in it, and multi-away and multi-close. Yes, as I've mentioned in the game, or if you played the game, there's this shine around the ball, this glow that gets bigger the closer you get to the final goal where the ball should land. And I'm achieving this by having 2 different effects on top. The one is this glow effect for the ball that gives it this nice glow, which essentially is just my glow object, which we'll just take a glance at later. And the other is this alpha stencil in the black void. And the one is called shine, and the other is called glow. So let's assume this is our view, and we have our ball somewhere here, and it has this shine around it. And the shine essentially is the light around the ball. So let's draw this here as our ball. And the glow, that's an effect that's on top of the ball. This is just the glow effect that's on top here. So the glow is this colored glow effect, and the shine here, the light that's emitting from the ball. So those are 2 very different things, but I just want to make sure what I'm talking about. Important here now in the create event is just that I'm using a max scale and a min scale, and here for the shine, the multi away and the multi close. So once we're the furthest away possible from the goal, the size is 0.3 of the default size, the shine init size, which is 3 for some reason. And when we are at the goal, the shine is 1.5 times as big as this initial value. So the appearance, the sprite is the sphere ball, which is just really this white circle. This is the first thing that I drew when I wanted to make a ball. And it's program art, but it's still in there. Then of course, image int, scale int, rotation int, nothing interesting there. And the shine effects and the glow effects currently are no one, which means I think it's the same as -1. But this keyword here, no one, tells me that those 2 variables are expecting an object ID, and the object ID we will get when we create a shine and a glow later on. Also, we have here flags, do init, do kick, to bounce, and in goal. Do init, I think, should be straightforward now. Do kick is, of course, that we should notify the ball that it has been kicked. This one gets true when the ball knows that it bounced off something. And of course, if it is in the goal, then in goal is true. And each step, as we've seen, the game control checks if the ball is in goal. So if this is true, then it's instant victory. Again, we set the default values for the appearance, like so. And we initialize the force and the kick direction to 0. And I'm also having here some debug values. And the ball also should know which goal to check for if it landed in. So currently it is no one. And the closeness to goal, this is between 1 and 0. The largest distance equals the room width. So very helpful comment. Usually you don't know what ranges you're in. The closeness to goal could also be pixels or maybe tiles or something. But it's really helpful that I said it's between 1 and 0 and 1. Good. Before moving on, let's just have here this draw event, which is really nothing special. It just draws the ball and changes here the color to red. But why does it change the color to red? Well, if we're doing some debugging stuff, or drawing a line. This debugging here just draws a line from the last collider towards the origin of the ball, so I know which collider made the ball bounce in a certain way. So yeah, actually we can delete this. This just changes the color, but doesn't do anything else apart from drawing the box if debug is true. But essentially in the final build, it should look like this. So it just draws the ball. Now what happens here in the step event? Also not much apart from some initialization going on. So again, we initialize the appearance, like so. Next up, we check if the goal exists, and if so, we assign the goal's ID, the instance ID, to this variable here, goal, so we don't have to look it up each frame, but we know that it's there because usually the goal shouldn't change in a game because nothing interacts with the goal apart from the ball. Now we have these shine effects and this glow effects. Okay. The shine effects, we create a new shine layer, and this is pretty interesting. We will get to in a bit, but we just say that this shine is its parent is the ID of the ball, and the scale is the shine init times the shine multi. As we've said here, it's the shine. So this is not this glow of the ball, but actually the light that's shining into the darkness around the ball. And if there already exists a glow effect, well, we destroy all glow effects when the ball gets created, just to be sure. And this glow effect, then we create a new, or we store the glow of the ball, which is, yeah, this yellowy, glow, because it's this glow effect. Yeah, we just store it in a variable we can access, and it's not a local variable. So because we need to work with it each frame, so each time, each frame, each step, we know how close we are to the goal, and this is why we need to scale this one here up and down, so we need to have a consistent handle to it. And this is what happens in the initialization. Now we are here with every frame. Okay, so first we check collisions. So the radius we're setting here a local variable is the sprite width times 2. So since we know here that the sprite has a radius is 64 by 64, so the radius of the ball here is 32 pixels. Why do we need this? Because I'm not using the collision mask of GameMaker. Instead, I'm rolling my own collisions, and I'm using a collision circle because, of course, the ball is round, and this is why we need to get the radius from the ball. I don't think we need to do this each step anew. Actually, this could be just a local variable or even a static one, which we just, upon create or in the doInit event, we just look up what's our current sprite, how wide is it, divided by 2, and that's always our radius. Because now this calculation, I mean, it's not a huge impact, but it's a calculation you do each frame, and it's not necessary. This is what this is doing. So we will let's store any collisions with the class obstacle collider in this local variable. And if the collision is not no one, we know we've just collided with an obstacle collider. Again, this is, let's have a look here in the room. This is this pink box with an X. So each of those pink boxes with an X is of the class obstacle collider. So this is what we're here colliding with. So if we're colliding with them here, just using those debug values here, but let's not be concerned with this, we get the direction of the ball. We assign the ball's direction, and this is my poor man's attempt at collision stuff, which is we get the point direction from the center of this collision box to the center of the ball, and use this there as the direction of the ball. So I just to give you a little bit demonstration of how this should look like, or how it looks like. Where's my fuchsia pink? There we go. So the ball is colliding with this one here, and we're having a collision, and the ball just collided with this one here. So the ball's origin is here, and the origin of the collider is here. So once we have a collision and the ball just moved into this direction here, what we do now is, as soon as there is a collision, we get the direction between this one here, between those two origins, and then we just move the bounce or bounce the ball back from the center of this collider. So the ball will bounce off into this direction. At what speed? Well, at the speed of the force minus the bounce friction. What is the force? Well, we will find out, but use the force, Harry. So, and this explains now, I think, why I'm using this shitload, pardon my French, this shitload of colliders here. As I said, it's 4,000 colliders. Why not use, I mean, of course, those are strange shapes, but why not use one just real big collider for each obstacle? So why not use a big collider here? Well, this is a little bit, I did this a little bit here at the wall colliders. Those are a bit bigger than those. The problem with these colliders is the bigger they are, well, the collision always happens at their center. And when they are small like this, I think it's 16 by 16 pixels, it's okay because, yeah, the fidelity is enough, at least for game jam purposes, that when we're colliding here, well, let's make a ball leg again, just to be very concise here. Now, if the ball collides now with this one, of course, it will bounce back into this direction. But if it still collides with this one here, it will bounce into this direction. So no matter what what direction they came towards this one here. So usually this works, and yeah, for game jam purposes, this feels okay enough. Maybe a little bit fidgety at some places and not entirely, well, a little bit random even. But that's okay. It's an action game, right? We're not a physics simulation. But the problem is now, if we have a collider that's, let's say, as big as this, well, it looks kind of as big as before, but let's assume now our ball is like this, and we just hit the ball here, and it intersected here with this collider here. So this is the center, so the ball will bounce back into this direction, no matter at what direction it came in. And of course, if we shot the ball like from here, and then it collided here with this one here, well, it will travel back into this direction. Or if the ball came from here, this is not a very straight line, I'm sorry. So if the ball collided at this position here, well, then it will bounce off towards this direction. So the bigger this collider is in relation to the ball, yeah, the more random the bouncing back will appear. But essentially, it's just due to this huge collider here. And this is why I placed a lot of small colliders, which is not the best. Even having here a gap, well, never mind. But I thought for the walls here in the beginning, it's okay if the fidelity is not too good. But this is what happens here. So, of course, we're checking if we are colliding with the goal. So if we are colliding with the goal, then in goal is true. So also have a comment here, game control keeps checking for that flag. So yeah, just to be sure that this happens each step. So, and the room bounce, this is nice. This is before I had colliders for the walls here, for each of the walls. This would just make sure that the ball would never leave the room. So if it collided here with the top, it would just bounce back, straight back, and from each direction. So just to reiterate things, if this is our room and our ball there would collide here, or the origin of the ball would lie outside here or threaten to lie outside, well then it would just bounce back into this direction. If it heads here now on left, well then it would go straight back into this direction, and the same thing for either side of the room. It would just go straight back. It's not even a Pong-like collision. Yeah, it just bounces back, straight back. And of course the movement. So if the force is, okay, so here the speed equals the force. Speed is a built-in value, so if you have a speed of something, then it will move into the direction of the built-in direction. Like I said before, many times I use my own variables, but if I use my own force, then of course I need to calculate and do vector calculations. And again, yeah, this is not necessary. For one thing, it's a jam game, and for the other thing, well, we have perfectly built-in values and variables for that, so that speed and direction is the same thing as if I would do the vector calculations, 2D vector calculations myself, but without the need to actually be doing it. So this is why I'm using speed and direction here, but also force. But yeah, this is not very consistent. As you can see, I've used force here, but essentially force is speed in this case. So if the speed or the force is equals or greater than 0.05, then we just deduct the ground friction, as we have it here in the create event. This is the ground friction. It is 5 divided by the room speed. So yeah, it's just a little bit that it gets, it's just friction, essentially. Very simple approach to friction. And why a 0.05? So yeah, that it's not overshooting or something. So if it's slow enough, then we will just set it straight 0. So yeah, if this one here is below 0.05, then there's no force and no direction. The ball just sits where it is. Otherwise, the ball would start dithering a little bit on the ground, because maybe it would land on 1 pixel, and then I'm deducting the ground friction. Now the force is negative, then it would go in the opposite direction, but then it would go in the opposite direction again, and it would just flicker about on the ground. And this is why I make sure if it's below a certain threshold, then it just stops. Yeah, again, the speed is the force. So the next block of code deals now with the ball's distance towards the goal and how to scale up the shine and the glow. Just to reiterate things here, the glow is this yellow glow that lies on top of the ball. It's the glow effect. And the shine is a different instance altogether, which simulates in a way this light that's emitting from the ball, which is just this kind of stencil in this black void that overlays on top of the screen. Okay, so now we are here at calculating our maximum distance, and it's the room width times 1.2. Why 1.2? Well, why not? Apparently, it's just the value that I pulled out of my ass. So let's roll with it. So the distance is the point distance of the current position of the ball towards the goal. So if the distance is smaller than 0.01, which means we are close enough, then we say the closeness to the goal is 1. And else the closeness to the goal is the maximum distance minus the distance divided by the maximum distance. What does this do here? Well, this one here just makes sure that our values are always between 1 and 0. This is why I had here in the create event this closeness to the goal, that it says between 1 and 0, so we can use this one here as a multiplier essentially, and don't have to do some kind of arithmetics ourselves. Yeah, we just know that closeness to goal is between 1 and 0. When we're in the goal, it is 1. If we're the furthest away, it is 0. Okay, now here for the appearance, these shine effects, again, the shine is this hole here, is the initial size of the shine times the shine multi times the linear interpolation, the lerp, between what the smallest size is and the biggest size, and the value of the value we are between this one here. Again, it's a value between 0 and 1. Is this closeness to goal here? So this is probably the reason why I made sure that this always is between 0 and 1. So I can use it just here in a lerp. And we also scale the glow here, which is this yellow thing that lies on top. Also, it's just the lowest glow and the biggest possible glow, and we just use a lerp and use this here as the closeness to our goal, and also for the alpha. So once we are in the goal, this one should be really strong and really yellow, and when we are far away, it should almost be invisible. So this is pretty much all that happens to the ball. Now, before moving on to the item, let's have a look at what actually happens in this shine effects, because I think this is probably the most complicated thing in this whole project, and I'm pretty happy with how I pulled it off. So let's have a look at Object Effects Shine. It doesn't have a sprite, but it is visible, but only because I'm doing some debugging apparently. And of course, oh my god, I'm already having here some errors, but we shouldn't be concerned with them. They are just errors here in the editor. Actually, this one compiles just fine. But let's start one thing after another. So when we create this one here at the depth of -110. So this one should lie even on top of the player, so that the player, once they leave this shine here, even with their health bars and everything, they just vanish. So I wanted to make sure that as a player, once you move out of this illuminated section here, that you are pretty much lost in a way. So this is why it sorts on top of the player. It has no parent when we started. It has no surf, which is a surface, which we will get into in a moment. The view x is 0, the view y is 0, and so on. There's no source x, and so on and so on. Just initializing my variables, and its active is true. Now let's get to the step event. So if the instance of if its parent doesn't exist, we destroy this object as well. So this one get created. I think it was in the ball. Right. This shine effect. So the parent is the ball ID. So once should the ball ever be destroyed, well then it also destroys this effect here that lies on top. So and what we do each step is, well, we get the view x and the y x when we're here in the game, which means just the position here of this white rectangle, which is the current view in the room. So it would be this top left corner here. And we subtract 10 from it. Why? Because this one follows now the ball, but it does so with a lag of 1 frame. So for example, when I'm kicking the ball now, just 1 frame, let's say the ball is moving into this direction here, and it was first on this frame and now it is on this frame. Well, this whole thing here, this whole black solid that's on top with the hole there, it just moves around like this. But as you can see now here on top, suddenly this one here wouldn't be black at all. So and this is why I said, yeah, let's make it a little bit bigger, so that no matter in what direction the ball travels, it always this black thing here always covers the whole screen. So this is why this -10 here happens. So the source x is the parent x minus view x, and the source y is the parent y minus the view y. And if we're doing some debugging, when we're pressing the tab key, then we can just switch off this black overlay in the game. But since the debug mode is off in the final build, well, this won't work. The real magic now happens here in the draw event. I don't think you should be doing this all in the draw event. No, you should be doing it in the draw event, because now we are working with surfaces. A surface essentially is just a texture in a way you draw to. So as the game is set up in GameMaker, it has a game surface, which is the default surface that all of the game gets drawn to, the background and all the sprites. So let's call this here now the GS, the game surface. But you can create also your own surfaces, which are just polygons with empty textures, or just textures you define. And you can say how they get blended on top. So this is what the GPU is actually doing. And you can draw onto surfaces and then draw the surfaces themselves. This is important because what I'm doing here now is I create a new surface, and the surface is, as you can see, 2K by 2K. It's not at the size of the screen, but instead it's the size that is friendly enough for our GPU, because otherwise if it always sorts to the next power of 2. And since I'm using a full HD, which is 1920 by 1080, I need a surface that looks like this, that actually is a little bit wider than our view here. So this is our game surface, and this is now the surface, let's call it surf, that I just created. By the way, those surfaces are volatile, which means that you have to check each frame really if they exist, and if they don't exist, to recreate them. Because volatile means that at any point, apart from the global game surface, they can be destroyed. And it's not even GameMaker's fault, it's maybe something of the operating system. For example, if you Alt-tab out of the game and come back in, or switch to full screen, the surface gets destroyed. So yeah, programming means for GameMaker that really make sure, if you're working with surfaces, just make sure that to redraw the surface or recreate the surface whenever need shall arise. So now once we have our surface, we set the surface as our drawing surface. Usually if we don't do anything like this, all the stuff here gets drawn to the global game surface. So all my instances and everything, just everything gets drawn to there, unless I specify a different surface. And in this case, I'm specifying now here the surf we created. And the first thing that happens here is draw clear alpha. So I'm clearing the surface. there could be still garbage on it or something. I'm just clearing it with pitch black, and alpha 1 means that it's completely opaque. So this GPU get blend mode X sep alpha, which means GPU get the current blending mode extended and with separate alpha, and this one returns now an array with 4 entries. Now let's have a look at the help to see what actually those mean. And the first one is the source blend mode minus the alpha component, destination blend mode minus alpha component, and the source alpha and the destination alpha. And I'm setting those now, the source and the new to 0 because it's just black. But we take here now the source alpha and the inverted destination alpha. Now, what the hell does this mean? Well, it probably should get clear once we see the actual sprite we are drawing now in this very new blending mode. And the sprite is the sprite FX Shine. And this is what the sprite looks like. It's white, and it has here now this gradient which was cut out in Photoshop. Let's get back to the code, and then I can show you exactly what happens. So we're drawing this effect sprite at source X and source Y. Remember, this is what happened here in the step event. This is the parent X minus the view X. Yeah, this is some gymnastics we're doing here now with coordinates. Now let's assume this is our room here, and our player here, our game surface, our current view, this one here, is somewhere here. Now what we're drawing, of course, the surface, we're drawing that the surface is always following the ball here. And so we need the ball's coordinates not within the room here, but within this surface here, because this one here is the origin, is 0, 0, and this one is the origin of the room. So we won't need the origin of the coordinates of the ball here within the room, but on this surface. And this is why we are using this kind of source X and source Y. Let's get back now here to this one. So we're drawing this sprite here at the source X and source Y position, the local position of the ball within the surface at this certain scale. And the scale is determined by how far away or how close we are to the goal. And that's pretty much it. And the blending mode takes care of the following thing. If we take a look at the sprite again. So let's assume now here we're in the room. This is our view. Now the view is red. Also make it red here. Yeah, so our game surface or our view is red now. And within this red surface is our ball. Let's say it is here, which means here in the game surface it is here, but in the room it is here. Now we've calculated the local coordinates of this ball here within the surface, which should be around here. So this is the origin of the ball. And at this position, because the origin of this sprite here, the dead center, has its origin, yeah, also here, we draw this sprite here, but with this kind of strange alpha blending. And it means actually we are cutting out this one here. We are not concerned with the color. I mean, right now it's white, but it could also be black or anything. Because in the blending mode, we're saying blending mode 0, 0, which means, yeah, just take black. And we're blending now the source alpha with inverted destination alpha, which actually, yeah, just means we're cutting out a hole. In the end, we draw this surface on top and can only see what's poking through this hole here with the half transparency, yeah, getting bigger or smaller depending how close we are. And this, yeah, like I said, this is the most interesting part that happens here code-wise in this game. And yeah, and if this one here is active, then this surface gets drawn. Yeah, just to close off this here. So we're drawing the sprite with this blending mode here. Then we reset the blending mode of the GPU to how it was before we made those changes. And then we reset target. So we're not drawing here now on the surface we specified. Resetting means that we're resetting it to the game surface here. And onto this game surface, we draw this surface here on top, like so. But of course, this isn't white. This is where the ball should be poking through. And yeah, this is essentially how this torch shine in a way works. Okay, now this was it for the ball and the ball's shine. Last thing we're going to look at is the items, and this shouldn't take too long. We have a class that's item, and there are a number of subclasses for each different type of item. Those subclasses are very short and really just change one thing. So this is why I'm mostly concerned now here with showing off the item class. So it has a sprite, and before continuing, it is important to know what this sprite looks like. Let's open it up here. And the sprites, the different icons for the different power-ups are sub-images, or image in terms of GameMaker. So this is one sprite, but this sprite here has now 1, 2, 3, 4, 5 sub-images. Yeah, this is just important so that when we say, we're using the same sprite for all images, but a different sub-image. Just to be clear on that. So as we can see, it is a parent. This item class is, of course, the parent of all the other items here. So now let's have a look at the create event. And also, I'm loving my enumerations, right? So the item type here is now medkit, stamina, max health up, stamina down, stamina multi up, last, and rand. So the appearance of the item, of course, is the sprite of the item. The default image is 0, which means it's this red cross on white. It has not a specific sound. It is not of a certain type. This comment here, random drop override. So this one means here it is random, and if we want to spawn a certain type of item, we just override the type value, and this is exactly what happens here now when I want to spawn a medkit. I'm just inheriting all those events, and in the create event, I'm just overwriting here now. I'm inheriting everything here that's in this create event here, but the only thing I'm doing is once this is done, I'm overwriting the type from random to medkit or random to stamina, from random to stamina multi-up, and so on. But apart from that, each item is just the same item, or that has exactly the same code as the class definition. Of course, it's not a class definition. I'm well aware of that. But yeah, just to be on the same page. It has no rotation. It has no draw color. Why I'm using draw color and not color will be clear in a moment. And the alpha is 1, which means, of course it is. We want it to be opaque. Again, when you see a local variable of I for index that gets initialized with -1, you probably know that I'm using some kind of array. And apparently I'm not using this here because I'm using IT for index type, apparently. So this one can go. So the stats, I've started using a lifetime of the item so that you have to pick them up real quickly. But in the end, I decided against it. So now the lifetime of all the items is 5,000 seconds, which still means they're not in the game indefinitely. But after 5,000 seconds, well, you should either have died or beaten the game. So I think this is fine. Okay, so now this local variable it, or IT, or item type. So what we're doing now is just assigning the different item types, essentially. You probably shouldn't be doing this in your code. Maybe have some kind of sidecar file for JSON or XML, or just separate your code and your data. And this is what I'm doing here now. It's pretty much data entry in the code. The current item type is medkit. And I'm using this IT item type, as you remember here, is also enumeration. So medkit is 0, stamina is 1, max health is 2, and so on and so forth. So I'm using this enumeration here also as the array index. I don't think you should be doing this because it's not that clear and probably error prone, but it works. So for each item type, like I said, I'm doing data entry. So the name of item type medkit is health up. The color is red because when we pick up, as we've seen with the player instance, once we pick up a health item, we create a glow around the player, and this glow has a certain color, and it gets this color from what we've entered here. When it's a health up, well, its color is red. When it's a stamina up, its color is green, and so on. So the image now here is the sub-image in the sprite. So for medkit, it is 0. For health up, it is 1. And for max stamina, it is 2, and so on. So yeah, you should decouple this here. Or yeah, it's a little bit error prone, but since it's only a handful, I think this is fine. And of course, we have a value min and a value max. So the value actually, if you recall, here in the player object, we're asking when we're picking up an item, what's its value? but we don't set the value. We only set a min and maximum value because the item, once it drops, runs a randomizer and it just returns a value between min and max as the value. And of course, which sound this item should play when we pick it up. So for medkit, it is the health sound. For health up, it is also the health sound, because I ran out of time for making different sounds. And for stamina, it is of course the stamina up and the stamina sound. And here we have the stamina multi-up, and its name is stamina recharge rate up. So we always know here when we just ask for the name what actually it does. And here you can see the value of minimum is 0.1 and the maximum value is 0.3. And if you recall, again, when I was at the player state machine, when we were picking up items, I thought, yeah, I'm always rounding this to the nearest integer, and this, I don't think this is kosher. And yeah, the problem will be because now that I see it, this one here is 0.1 and 0.3, so it will always be rounded down to 0. So actually, when you pick up a stamina multi-up, it won't do a thing because it will just get added by 0, which means, yeah, it has no effect at all. Okay, so we also have here a weight. What does this weight mean? Do we have an inventory system? No, we don't. This weight is actually a weighted randomness. And this is the other cool thing that I did here, because it's the first time that I implemented a weighted randomness. So it doesn't matter the actual values here or at what they add up to. It doesn't have to be 100 or anything. It could be random. But 30 means that the medkit is 3 times more likely to spawn than a max health up, for example. And the stamina multi-up, for example, is a very rare drop. So yeah, it's not so much about the values themselves, but about the differences between all those values. Again, do init is true, and some process variables for this image, this sound, this name, this color, because when I'm using just name or color, well, it refers to this. Essentially, it's a database. Those are all arrays that essentially make up the database of the different items that are in the game, conceptually. Okay, so this is now the create event. So we're creating, with each time an item spawns, we're creating arrays. So we shouldn't be doing this on a per instance basis, rather have this, like a global database, and then upon creation, each item pulls out what it needs. Yeah, but instead I'm doing it like this. This is fine. I'm not having a lot of items, but I know that this is flawed. Okay, so let's have a look at the step event. So the first time we drop an item, its initialization runs. And here happens a lot during initialization. So if the item type is of type random, well, we should get a weight. And this one here is the get weight random. So usually when we drop an item from a zombie, it's a random item. And as you can see now here, the default type is of type random. And only if you're using one of those objects here, then their item type is not random. So with each zombie, this item type is random, and with each manually placed item here that I did here in the room, I mean, those always have, as you can see here, have the same sprite, because I can't define a certain sub-image here, but those are actually different instances. Okay, so now that we know that the item type is random, we will get a weighted random with a weight. Again, here we go back to the create event, to this weight. As you can see here, the weight now is also an array, and the array index, again, matches now here the item type. So we have a relation here between item type and the array index here now in, let's call it our database arrays here for name, color, image, and which also has a weight. So when we take, for example, here, for this IT, when we say weight IT, it is actually the same entry here as I'm using here when I'm saying weight type stamina multi-up. So yeah, IT in this case is exactly the same. And we are passing this array to this function of f get weighted random. And the type it returns is the type of object to spawn. Now let's have a look at this function, what it actually does. It is pretty simple. It just sums up all the weights gets a random integer of the sum of all the weights, and then again goes through all the weights and it just subtracts the value. And once the random value is below the current weight, well, then the current array index that we are at, well, this is the item type that we return. You can just Google weighted random and you get probably to a Stack Overflow page, and this is the algorithm that I took from there. So thank you, Stack Overflow, once again. So yeah, the return type we get now here from this function here is the type of item to spawn. So we say this image is the image of type. And again, the type is now the array index. And if the type was stamina, then it is this one here, and it returns the name stamina up. So this name or this image is the image stamina up. The value is the random range between the value min and the maximum. So at this point, we don't care, or the code doesn't care what actual type it is. It only knows that, yeah, it has a value min, value max, it has a color, it has a name. It could be anything because this all gets defined here within those data entry arrays. And we switch its visibility to true because we spawn it in invisible, because when we spawn it, it gets drawn for one frame and then it changes its appearance to match what we assign here in the doInit. And this is why I'm spawning it invisible. And once we've assigned everything of color and name and appearance, then we switch it to true. And of course, when we create it, it should also start with a nice glow around it. And this glow is static, which means it doesn't fade out or get away. And this also is in front. This is very important that I made sure that the glow actually is in front of this surface here. So if we draw it, the game, let's draw it some isometric way. So this is the game surface here. And on top here, we have the surface with a cutout for the ball. Let's fill it up with black. So at this one here is transparent. And on top of this, should we have an item, let's say here, on top of this, then there's this glow effect for an item. So we've spawned an item, got its type, and from this type we know which image to display, which value it has, which sound it has, which name it has, and then we can just deduct one step from its overall lifetime, and once its lifetime runs out, well, it gets destroyed. And as for drawing, yeah, pretty much we're just drawing the sprite with this image and at the position that it was spawned in. So this image is the sub-image, and the sub-image is the item type, as we have here. I hope this makes sense. As we've seen, I've used oftentimes the object fxGlow, and let's have a look at it here. The fxGlow, I've coded this up a long time ago, and during the jam I ported it to GameMaker Studio 2. But essentially, yeah, you just have a lot of parameters to pass just to make a glow. You can you can say the starting scale and ending scale. Should it match the parent size? Do you want to kill it with the parent? Does it have an offset from the parent? What's its depth? How long should it last? And here in the step event, this is all the initialization. And with each step, if it fades in, should it fade out? Yeah, this is all what happens here in this event here. And we have a draw and even a draw end state. This is for draw late. If we're doing it draw late, which this means, right, I recall now, that all the drawing to the game surface happens of the cold game, and draw late, this is after all the drawing is done. We can still do some drawing if we're really quick. So sometimes you want a glow to be the last thing that's drawn, and this is why, for example, I implemented this draw late. But yeah, you just create this glow object and it takes care of itself. It destroys itself when its alpha is 0, or after if its lifetime is up, or its parent got destroyed. Yeah, this is pretty much a simple glow object, but I think it's very neat and very handy, and I can use it very often. Oh, right, the text object. This text object, you often need to display some kind of text in a game, right? Just your heads-up display, or just some notice, or just press E to interact, or something like this. And I never do this. I never get it right. And for this jam, I thought, yeah, let's really create a very basic text system, because I had this typewriter system that I used for the seller, which was way too much for just this little thing here, because I don't needed it to be displayed one character at a time or play a sound or something. No, I really just want to write, you picked up health or something. And this is this object text here, so it's very generic. And I'm also using an enumeration for the text position. So TL, top left, top center, top right, middle left, middle center, middle right, bottom left, bottom center, and bottom right. The content is the text that's to be displayed. The font is just the default font or any font you give it. Of course, we are going to initialize it. And of course, you can set the color of the text, the color of the shadow, should there be one, some kind of alignment. Do you want a vertical alignment and horizontal alignment in GameMaker terms? You have some text here, let's say text. And if the alignment is middle, then its origin is here. If the alignment is left, then its origin is here and right is here. This is the horizontal alignment, and the vertical alignment here is bottom. Here, of course, is center, and here is top. So this is how you can align text. When you say vertical alignment top and horizontal alignment center, well, then the origin will be of the text box will be here, for example. So and you can just give this as options to this text box here. And I'm also having here a margin. You can specify a margin. Right now it's here hard coded in this object, but this means here it's 100 pixels from either side. Because when you say you want to display a text on the top of the screen, you don't mean like this on top of the screen. You want it probably to be displayed like here, so that it has a nice little, it's a margin from all the edges. And when you say, when you create a text, like I said before, and you want it to be on the top left, it doesn't get drawn here, but it gets drawn here. So it has a margin that it just looks nice. And of course, this text also has a lifetime. And once its lifetime is over, you can have it fade out. This is why I'm using the alpha step. And you can say it should follow the parent. Does it have a shadow? And how far the shadow is away from the main text. So here now in the step event, and this is also why I'm deferring the initialization, because we don't know what the text is or anything. We're just setting up here default values. And once whatever created this text object, it then overwrites these values here with the actual values that should be displayed. So now what I'm doing here is I'm just getting the current window width, height, and the current window position, so that we know where actually, how big, how wide, and how tall the window is, so that we can find out, what are the actual coordinates of this frame here in which we want to draw stuff. And this is just what this here does: right, bottom, left, top. And then we just switch the text position. So when I'm creating this and say here, I want a text position of TL, then we're just switching the text position. TL means align V. So we are aligning the text here. And this is text, and this is the text box it is in. It is aligned on, of course, the top left, and then we're drawing this with top left here, so that the text should be here. So it's when you say you want a text in top center, you don't have for each text to provide the coordinates yourself. You just create a text object and say, I want it to be on top center. And this is what this text object does. You can also specify an offset, of course. You don't want it to be always dead center. You can say, I want it dead center, but 100 pixels up. And this is why you can specify here an offset. Depending on the lifetime, I just calculate by how far or how much to decrease the alpha each step so that it fades out. And this is what every frame does. It just ticks down the lifetime. And and if the lifetime is less or equal than 0, well, it destroys itself. And lastly, draw GUI means no matter where in the room we are. So let's say this is our room, and this is our view, and we're here in the view. Well, when I'm drawing, for example, the score, should we have a score at coordinates 2020, then it's not in 2020 here in the room, but always here local to the view space. And this is what draw GUI means. Actually, it draws just on top and in the view space and not in the room space. So if we're not following the parent, then we do this. Otherwise, when we're following the parent, actually this should not happen, of course, in the GUI, but it should happen there in the room coordinates. And this is why I said, if not, do follow parent. So this is not fully implemented because, let's say it with me, I was running out of time. So, but this is why I have this Boolean value here. So the color is, well, get the draw color and get the draw alpha, because I'm overriding now what's currently the color and the current alpha. So this is why we're storing what the GPU is currently having as default color and default alpha, and we're setting it back here. And here now we're setting the alignment of the text box, like I said, the horizontal and vertical alignment, set the font, set the alpha. And if we are doing shadows, and doing a shadow means just to draw the text twice. So for example, if I want to draw a red text or a blue text with some shadow, or let's just draw this T here so that don't have to draw that too much. So the first thing I'm going to draw is now here the shadow at an offset. Usually in my case, it's 2 pixels to the left and 2 pixels down. And this is what this does here. So we just, as a value of O, we take the shadow offset, set the draw color to the shadow color, and offset, draw the text with this offset. And once we're done with the shadow, should there be a shadow, we switch the normal color of the text we want to draw, let's say blue, and just draw it at the original coordinates. In this case, it's offset by 2. And look at this, now we have a T with a shadow. And yeah, this is pretty much my implementation of drawing shadows. Lastly, the goal. And the goal, yeah, it's really simple. It's just an object. Does it have a glow effects? None. And it starts with a do in it. And since I'm setting up here a variable for glow effects, I'm apparently assigning here a glow effect. So once we create this thing, I place this one here in the room in the editor, which means it gets created when the room gets created. And the first thing it does, it shows a debug message of its X. I think I used this to debug the distance from the ball to the goal, because this happened each frame. And then I'm going to just create a glow effects, so that the glow, there's always this big yellow glow that's on top of the goal. So when you're getting closer to the goal, there's really this very wide, it's like 3000 pixels wide, this very subtle glow, this streak of yellow that's the same color as your ball, so you know you should be kicking it into this direction. And this is all it does. Once it gets created, it creates a glow effect on top of it, and that's it. It draws itself, and that's the goal. Because when the ball is in the goal, or if it's in the goal or not, well, this happens in the ball object, as we've seen, and the game knows that we've won or we've lost by querying the is in goal Boolean inside the ball instance.
Wow. So thank you if you're still watching this. Thank you for watching. Thank you for your interest. Yeah, this was the code review of Zoccer, and I hope it was insightful to you, it was useful, or if you're a programmer, you got a good laugh out of it, right? So yeah, thank you for watching, and see you next time, and it's for me back to work, so I still need to motivate myself with this. Barb a papa. Oh my god, it smells horrendous. I like it already. It's like bubble gum mated with a coconut. I love it.